Hello. Hello. Welcome to part 19, nearly at part 20 of me writing a WebAssembly interpreter in Ruby. So that's why I'm here. That's what we're doing. As always, same as usual. I'm here to have fun, mainly. I would like to demystify WebAssembly if possible. I would like to share how I've implemented a WebAssembly interpreter if possible. I want to prioritize having fun over making something that completely works. I want to write correct code, even if that means it's not as fast as it could be. I want to write clear code, even if that means it's not as clever as it could be. I'm doing it in pure Ruby. I'm trying to do it without any dependencies. That's the deal. So, before I start typing, let's do the usual thing of having a brief retrospective on what happened last time. Last time was quite good, actually. I was very happy with the progress on the previous stream. I got, I think, 7 new test scripts passing. And 7 is definitely a significant improvement over what's happened in recent sessions. So I've had several sessions where I haven't made any new test scripts pass. I was stuck on float express and on if.wast for a while. So yeah, that sort of feels like a step change. Now, to make more progress, there are 2 things I need. Firstly, I think I need to make some improvements to the parser so that it's able to support, some of the problems with tests that weren't parsing were actually parsing problems rather than, me not having implemented something. So I need to chip away at that. And then, of course, straightforwardly, I need to add support for some more instructions. So obviously, there's still loads to do. So out of the 90 test scripts that there are in the WebAssembly test suite, I think 27 of them are passing now. So we're not even a third of them passing, but that feels like a decent chunk. And it feels good to have had sort of a spurt of progress. And if I had a graph, there would have been like a little step on the graph that showed that I'd suddenly made some progress. So I don't know. I just wanted to acknowledge it, basically. Like I said, I think the parser, specifically the AST parser, does need more love. I've been banging on about the need for an identifier context for several streams, but I haven't done anything about it. So I think I'm going to have to force myself to have a look at that today, even if I don't want to. I've been sort of shying away from it because I assume it's going to be, I don't know, boring or fiddly or both. But I don't think I've got a choice, really. I've just got to make it work. I'm also concerned that the AST parser is sort of half finished because I created the AST parser by extracting all of the expression parsing stuff out of the interpreter. But I haven't done the same with the module parsing stuff that's still in the interpreter. So things like function definitions still get parsed in the interpreter, which is not right. So I think my highest priority for this stream is to sort those problems out before they cause me any more grief, and before they cause you any more grief by forcing you to listen to me complain about them still not having been done. Also, finally, I saw in my inbox that I had a pull request from Chris Zetter. Thank you very much, Chris. As with the PR that Ufuk opened, I've not looked beyond the subject line of that email. At least not yet. Because I'm not sure of the best way to... I'm not sure of the best way to make use of viewer contributions while maintaining the purpose of this project, which is to make videos of me struggling to write code rather than to be a sort of, collaborative open source, dreamland. Um, so I'm going to think about that a bit. Maybe I should. I've been thinking about it today, and I haven't really come to any conclusions. I mean, those. Oh, hi, Chris. Hello. Just speak of the devil, and there you are. You're on a train yet again. So yeah, like I said, I've been thinking a bit today about I should have thought about this at the beginning. What's the policy about contributions? Are pull requests welcome? Am I gonna merge other people's contributions, or am I just gonna use them as comments or inspiration? I haven't quite decided. I should just make a decision and write some contribution guidelines so I don't have to agonize about it every time. But the short version is, thank you very much for your contribution, Chris. I really appreciate the PR, and I'm grateful for your participation. And maybe I'll get to that PR on this stream, or at least in due course once I've worked out how to how to handle pull requests. So I think that is probably the end of this bit, which means it's now time for this bit where I do some typing. Let's just check all the tests are running. They do seem to be. I'm going to clean up I can see that I left myself some notes about what to do in this stream, but some of them are already done. If I've got any other done stuff that I can get rid of. This is actually, although at the beginning it's nice to see all of the stuff that's already done checked off. After a while it gets a bit oppressive, so this is better. Okay, so previously on this, yeah, oh, right. Yeah, okay. So as you can see, I'm still... I had to work on the parser in order to get stack.wast parsing. But as you can see, that was the fragment of the parser that still lives in the interpreter. So yeah, all this stuff here, iterate over all the expressions and see what kind of thing they are, and look for certain shapes of expression and treat them in certain ways, is all very parser-y. So I think that's a sort of a good example of the kind of thing that I want to try and deal with. What did I put on my plan? Introduce an identifier context. Yeah. I know we need to do that. Oh, okay, thanks. Chris says in the chat, don't expect PR to be merged, but wanted to share idea to help with loop. Great. Okay. Well, hopefully I'll get to that this time then, and we can take a look at that. Yeah, I suppose I want to, the thing I want to get straight in my head, this has nothing to do with your pull request. It's more about me getting straight in my head, given that the purpose of this project is essentially to produce videos rather than to produce software, what's the best thing with respect to video content for me to do with stuff like that? And I'm not quite sure, but I'm gonna think about it. Yeah, so anyway, what am I doing here? Identify context, implement nested comments. Oh yeah, that's another thing that I forgot. I punted on that. The S-expression parser doesn't support nested comments, which they look like this. I think that's right. And they can be nested. So I sort of shied away from doing that because it just seemed not very interesting and I didn't need it. But global.wast is being blocked on that. So that's another parsing concern. This might be a parsing episode of this project, so I apologize for that. And Chris, I apologize if I end up spending the whole stream on the parser and don't get to the loop thing that you'd made better. Parse function body once at definition time, not every time it's executed. Oh yeah, I think I might have moved this in here actually, because one of the things that I felt sad about last time was how incredibly slow some of the tests run. Is it cool? Yeah, because how long does that take? So I mean that, you can see it's and this is, I think it's calculating factorial of 20 there. And you can see that it stops for what feels like about a second, calculating the factorial of 20. And I was really disappointed when I saw that. And then I was thinking about it over the weekend and I thought, although I'm trying to remind myself at the beginning of every one of these streams that I'm not, that performance is not a primary concern. There's definitely a sort of developer experience thing here where it's like, it's not good for me for the test to take too long to run. So I'm not going to start refactoring everything to try and make the tests go as fast as possible. But that kind of thing sort of bothers me. And anyway, what I thought was, it's probably spending most of that time doing parsing, because every time there's a recursive call, invoke function, we kick off the AST parser to parse the body of the function. That's completely unnecessary. We should just be doing that in define function. So I put that there because I think that could potentially be a really a bit of low-hanging fruit. So I'd like to try making that change and then see whether it makes this test or the whole test suite any faster. So that seems like a gimme, basically. Oh yeah, support parsing modules, function definitions, etc. So that's the kind of pulling all the rest of this rubbish out of the interpreter and into the AST parser. So, you shouldn't have things like parse string and stuff in here. Like, the whole thing is just very, very ill-advised, in my opinion. So, yeah, I'm going to have a look at that. And then the sort of stretch goals, I suppose, are... what does it say here? Actually look up indexes in an identifier context. Right. So that's more, that's more advocacy from me to me about, about, making an identifier context so that I don't have to constantly complain about it. Refine data with, oh yeah, that was just a little thing about, because I implemented with sign on the floats, it occurred to me that I could actually just more generally refine data to give it that. What's the bugs rubylang.org? Is that the name of the thing? Issues. I can never remember how to use this. View all issues. Add filter. Description. Data.with. Oh. There we go. Add copy with changes method. That's it. So there's I'll bump the font size up here a bit. Oh, this is easy to remember. 19,000. So there's a proposal here about having this with method that allows you to just do this with some keyword arguments, and I think Afuk has made a PR including the name dupe, which I left a comment saying that I didn't like that name. I think it should be with. So there's obviously a bit of there are some decisions to be made there. I mean, obviously, the person who opens a pull request that implements the language feature is quite likely to win that disagreement. But for now, I can just refine. I can just refine data and call that method what I want it to be called. So until Ruby 3.3 or whatever comes out, I don't have to worry about that. Try Widget, set as PR. Let me find a link to that. I haven't read this at all apart from seeing the title of it. Make loop more like block. So that sounds, I really like the sound of that. So might look at that. And then, yeah, as I said here, write a contributing.md so that I can just to help me think about how I want to deal with contributions more generally, so that people can open pull requests and issues without wondering, is this, what's going to happen to this? I just want to make it clear what's going to happen to those things. But, it's up on GitHub, so I need to do something when PRs and issues come in. Okay, so I'm going to try and stay focused on this. I mean, I think this is the gnarliest bit, introducing the identifier context, and it's also potentially the highest impact bit. But I think all of these non-stretch goals are things that I do need to. I mean, this stretch goal is really part of that. I think this is all important. I think if I can get all of this working, the combination of these two things, well, That one's going to make it a bit faster, I hope. This one is going to dramatically simplify the interpreter, and I think that's the motivation for doing this as well. Is this means that the interpreter doesn't have to know about names of things. It just all uses numeric indices. This means that the interpreter doesn't need to know about, well, parsing. So that would also be very helpful. So let's start with this, because this parse function body once at definition time seems like an easy win. So I've already got this. I suppose I can do some performance measurements afterwards, but that takes like 1.9 seconds basically. So I think probably I can just, because I was just in invoke function, I think what I should do is arrange for this function dot body to already be the abstract syntax tree, right? So where does that get set? I suppose it gets set in define function, because I think that's where we collect all of the expressions. Yeah. So here again, it's basically parsing. This iterates over all of the expressions inside the function definition, and if it's any of these special expressions, then that has an effect on the definition of the function. Otherwise, we just collect those expressions into the function body. So I think by this point, before it gets injected into this and we just call the constructor of the function class, I think this is my opportunity to, once all of these expressions have been collected up, we can turn it into an AST. And it's sort of important that we do it in that order, I think, because let's look at some examples. If we look at a simple one, like, well, in fact, why don't I know that float expres has got both kinds, so let's just look at this one thing. So, in some cases like this one, this function body has only got one expression in it. It's just this one big folded expression, f32 add, with all these arguments. So, in that case, we could just parse that on its own. But the example I'm thinking of is our old friend tau. So as we spin around this loop and we pull individual, expression isn't even the right word for it. It's just a list element, whatever comes inside this func block. And, so it could be a nested list, but it could also just be an atom. It could just be f64.const. And clearly we can't parse that on its own because it doesn't even have its immediate argument. Likewise, local.set you can't parse on its own. It hasn't got its immediate argument. So we need to accumulate them all into this. This starts off as being an empty array, this body array. And then when it's finished accumulating them, then we can parse it. So I should just be able to do function body equals ast parser dot new dot parse function body. So I think that's all we need to do is just move it earlier, and then that means that this is now this AST is now stored inside the function node in the abstract syntax tree, rather than storing that big list of expressions and reparsing them every time. So let's see, firstly, if that works, and secondly, what effect it has. Okay, well, that's dramatically faster. Rather than 1.9 seconds, that's 0.35 seconds. So I'm really happy with that. That's great. Let's say parse function bodies during definition, not execution. This makes execution of especially recursive execution of functions, especially recursive ones, significantly faster because the function body only needs to be parsed once. Okay, and I will just run all of the tests to check that that's all fine. So I think we're done with this. What do I want to do next? Oh, poo. Okay. All right, well, that didn't work. Okay, so it's failing on stack.wast. Why is it now failing? Parse normal instruction, $body, no matching pattern error. Okay, let's have a look at stack.wast. Okay, so it's failing in here, I assume. If $body, else $body, ends $body. Oh. Oh. Okay, so hold on. We don't support this syntax. This, so this is, how annoying. That's wrong. Text format, I think, is where it talks about this. I remember seeing this before and thinking I could ignore it, but of course I can't ignore anything. So what's going on here is that you can, in addition to labeling, I mean, yeah, I can see this is happening for the block and the loop as well. In addition to labeling the block, or labeling the structured instruction, you can also label, well, you can label the end to sort of, I think this is just for documentation purposes, and it's apparently you can also label the else. So what does this say? The same label identifier may optionally be repeated after the corresponding end and else pseudo instructions to indicate the matching delimiters. So it's sort of a, you know, yeah, it is sort of documentation. In addition to indentation, this can help to clarify, well, what does this end belong to? Because it's just an end. Oh, it belongs to this $loop. We don't support that yet, and I mean, the thing that concerns me is that suggests that this, I hadn't actually thought about this, but I guess it's actually not surprising that this has caused some fresh problems, because previously we would only try to parse the body of a function when it was executed, and so I assume for one reason or another we actually weren't executing this function. Maybe this is called by one of the assertions that we don't implement yet. Oh, no, it's just completely dead. It's not referenced anywhere. So there's fac expression, fac stack, fac mixed. And then there's fac stack raw, which is an unfolded, well, yeah, it's an unfolded version of the other function. So you can see this one's nicely nested. These instructions are all folded. Okay, so I'm not sure why this is here, but maybe it's just here to stress test the parser, but previously it wasn't doing that because I wasn't even trying to parse this because it doesn't get called anywhere. So, okay. Well, that's going to mean that I need to yeah, I mean, I'm just thinking, is that definitely the problem? But it does certainly seem to be like this, that it's trying to parse an instruction, and the instruction it's trying to parse is I assume it's here that it's causing a problem, because I think we support labels after, yeah, we do. I remember we do. After block, done, and loop. I guess this is in the AST parser, actually. Is it parse structured instruction? Yeah, so before we try to read block, loop, or if, we will actually try to read a label. So this might be a little bit fiddly, actually. We're going to need to... So which one is it? Oh, this is for... It's for if, else. That's annoying. Okay. Well, I'm just gonna think about how we want this to work. The reason it's a bit annoying is because we've got these inline expressions here, but what we're going to need to do is parse the expression terminated by else, and then we're going to have to check to see if there's a label, and then parse the expression terminated by end, and then check to see if there's a label. So that's not too bad. So it's going to be something like... Oh yeah, I should also remember that this... Okay, hold on. So this commit is actually not yet good. Oh, but I was going to get rid of it. But maybe I should just remember that it's not good because I want to know if I fixed it. So I'm going to... Maybe I should just do this. So I don't have the commit anymore. Yeah, okay. And I just want to keep the changes so that I'm... So that I can still run the tests. So this is consequent. This is alternative. So once I've... So these should be okay. In fact, this whole thing I think can be tightened up a bit now. So after we've parsed, so we've parsed, you know, if, okay, we've parsed if $body, and then we've parsed br $done, and now we're else, terminated by else, and now we've got the possibility of there being the same label repeated again. So it's actually not any label, it's like the same label that was provided up here. So, but the label wasn't necessarily provided. So this is something like if the label's been provided, and let's look at the next token. If the next, well, no, it's not a token, is it? The next thing is this atom. So it's another atom that's equal to the label, then we can read it. And then I guess the same thing here for like optionally reading the label. I mean, that seems okay. I think that should be all right. Let's run the whichever test it was that was problematic. Oh, I think I was doing it here. Yes, stack.west. Okay, still not happy. Parse normal instruction $loop. Oh, okay. All right. Okay, that's fine. All right. So I think we dealt with the $body, and now we've got the $loop and the $done. So I'm hoping that if I just copy that code and do it for loop, then then we'll see it fail for block. So something like this. If I, oh yeah, okay, we're gonna have to do this similar thing here, aren't we? So this will need to be body equals that. Pass that label. Right, and now it's complaining about $done, which presumably is coming from that end. So just same thing again. So yeah, some more code duplication here, unfortunately. I mean, these two things really are extremely similar, aren't they? Maybe that's something I should fix. Why is it saying git stash? Okay. All right. Parse normal instruction nil. Nil does not respond to deconstruct. So something's gone wrong somewhere. Okay, that's not very helpful. All right. So anyway, though, I think I've made progress there. I think the kind of progress I've made is that I've added support for those optional labels. So if I just temporarily stash that breaking change, then hopefully, you know, that hasn't actually broken anything, but it's got us closer to being able to parse. So, okay, well, maybe the big picture here is that maybe this wasn't such low-hanging fruit, because suddenly, now that we are actually attempting to parse every single function body, whereas previously we were only parsing a subset of function bodies, now there's going to be, I don't know how many of these problems there's going to be, is what I'm trying to say. It's going to flush out any annoying failures. Support optional labels after else end for structured instructions. And then I can probably link to this. I'm just going to copy this because that's pretty good. Structure control instructions combine an optional symbolic label identifier. The same label identifier may optionally be repeated after the corresponding blank and blank pseudo instructions. And and else pseudo instructions to indicate. I didn't want that, did I? if anyone knows how to do this properly in Vim, please write in, because I don't. Structure control instructions by not symbolic label identify the same. Yeah, okay, fine. All right, so we do need to be able to do that. However, we have other problems. In fact, why don't I run the whole test suite? I don't want to fixate on that. Oh no, that stack was the first place where something was failing, wasn't it? So I maybe should fixate on it. Okay, this is stack presumably. Yeah, okay. I don't need to time it anymore. That's the brief moment of basking in the glory of the test running slightly faster is over. Okay, hold on. I think previously it wasn't successfully executing anything, and now it is successfully executing 5 assertions. But that doesn't make sense. Oh, it does make sense, because the parsing... Yeah. This is another problem. Because the parsing is interleaved, so that the parsing is done up front, but it's actually interleaved with the execution of the assertion. So like we go through the test script, one top level command at a time, and some of the top level commands are module, and that actually defines a bunch of functions, and then some of them are assert, and that invokes those. But then there's more, you know. Oh, in fact, in this one, okay. So in this one, I think it looks like there are only 5 assertions. So like previously we were crapping out when we tried to parse this module because of the label situation. I fixed that now. So the parser is chewing through all of that successfully. It's all 5 of these assertions are passing, which is good. Well, they previously were anyway, so we knew they worked semantically. And now there's this syntax of flat call indirect that sits right at the bottom and doesn't seem to be called anywhere. So again, this is another piece of dark matter, right? That like, there's obviously something about this syntactically that the parser can't handle. And I was blissfully unaware of that before, because this was just being stored as an S expression and it never got turned into an AST. But now it is being. Okay, so I guess we have to do a bit of debugging to figure out like what the actual problem is, because this is just saying nil. So where in the call stack is this happening? It's inside parse instructions. So let's have a look at, let's use my old friend puts and see how far we get. I wish, again, please write in if you know a way without me installing, you know, the RSpec backtrace cleaner or whatever. If you know a way for me to make this backtrace less intrusive, because I really don't need a whole screen full of backtrace. I just want to see the error message, and the fact that it scrolls all of the useful information off the top of the screen is actively unhelpful, I would say. Okay. So why don't we, before I continue with this, why don't we do the usual thing of making a copy of that here. And then I think we're reasonably confident that it's just this bit that's problematic. So before I pour over that, let's just stack.wast. Yeah, okay, so that's failing in the same way. So the hypothesis was correct. So it starts out with the entire S expression of this function body. And yeah, this has been unfolded. So we can see block, I32 const 0, call indirect. That's fine. End. Yeah, so the unfolding has correctly inserted an end that matches the block. So superficially, this looks fine. And then we go to I32 const 0, call indirect. Right, so this is the contents of that block. I32 0, call indirect. And then we just got call indirect. And is that what's causing the problem? Ah, okay. So call indirect takes an optional. Well, looking at this, I assume that the type is optional. So here, previously we were saying, previously we were just assuming that we had to read the type. Whereas now it would seem that it's optional, which I didn't realize before. So yeah, I think I'm just gonna have to can I just make this in? Like, does it need to be anything more complicated than that? No, hold on, my brain's still booting up again. Because we only want to read it if we know that it's going to match, we need to guard this. So this needs to be if peak in. Something like this. Type. And then, yeah, whatever this is supposed to look like syntactically. So we peek ahead to see whether we can consume it, and then we do consume it, and we pull out the type index. Yeah, that makes sense. I assume unfolding needs to know about this as well. Right, so we've got like the optional table index here, but then we've got this ostensibly mandatory type, and we can just make that optional as well by saying we'll allow that to fail, and if that doesn't match, then it won't touch rest. Yeah, it's another kind of uncomfortable thing here. There are many uncomfortable things, but one of the uncomfortable things is that we've sort of got two different styles, you know, inside the parser proper, we're doing this sort of destructively consuming the S expression business, and effectively sort of shifting atoms and arrays off of the beginning of it, whereas in unfold we're still doing this thing where we're sort of we're not destructively consuming it, we're just matching it against something that's got like a head and a tail. This is actually all a bit of a mess. I hadn't really appreciated how much of a mess I'd made here, so I feel a little bit embarrassed about that. But we will soldier on, and then I can always do some refactoring another time. Okay, well that hasn't fixed it. Okay, but it's got a lot further. So that did semi-fix it. So again, I think, yes. I think I can save that AST parser change. That stuff's not good. But that's good. So I can just say make, what is it, type blah, immediate argument, optional for call indirect. Okay. But now now there's some other problem further down. So let's just try and track how far it's got. I mean, I'm worried that I've got more than one running into it, running together there. Oh no, maybe not. It really is that long. Okay, so that's the whole thing. We start off with I32 const 0 call indirect. Fine. Excuse me. Then we're looking at the loop. And the body of that loop is I32 const 0 call indirect. Great. Oh, this I32 const here is because that's the condition of this loop. So the if's been unfolded. So if I32 const 0 call indirect, then I32 const call indirect. And then, yeah, okay, so that's all working. Okay, this is boring, isn't it? Okay. I32 const 0 call indirect proc type. Well, that's not right. It should be type proc. So I assume it's this one, actually. Yes, the block here. I32 const 0 call indirect type proc. Let's just have a look at that. So I think the problem is here. Let's see. Yeah. Module type proc funct. Yeah, okay. Okay, actually, I can get rid of those. So the only thing I care about is that block. Right. So this gets unfolded. So this is block I32 const 0 call indirect. Right. So this is okay. Oh no. I hadn't thought about this. Okay, so there's an annoying problem here, which is call indirect can take this type use argument, and this type use argument is in parens, right? So this looks like parens type x, or this is an ID, right? So this can be $proc, as it is in that case, or it could be a number, I think. But looking at this, what's happened is that the unfolding has just unfolded it. So it's taken this type proc, and it doesn't recognize this type. It doesn't know what that is. And so it's just treating these two things as though they're unrelated. And it's unfolding them. So that means that you get proc first, and then you get type. And then you get end. So it doesn't know. Okay. I think that, sorry, the reason why I'm being a bit dramatic and sighing and stuff is that I think this is actually a sort of a fundamental oversight in the way that I'm doing unfolding, which is the way that I unfold stuff is that if you give me something that isn't even folded, so if you give me this, So you can tell it's not folded because it doesn't have any parentheses around it. This is just a sequence of atoms with no opening or closing parentheses. Then it just passes through untouched. There's some code somewhere. Where do we decide? It's not there. Somewhere else. Okay, we actually don't decide. Right, yeah, because of this fall through. Okay, yeah, I mean, I think when I wrote this code, I was nervous about how slapdash it was and how blunt this instrument was, and now it's occurring to me that it's too blunt to be useful. Because, sorry, I haven't properly characterized the problem. The problem is that, well, essentially, the source of the problem is that this is a mixture of folded and unfolded expressions, right? So this outermost if is folded. So this all gets processed. You can see that in unfold, if you give it something that isn't an array, like this is the final fall through that says, well, if you've got an array that just contains one thing at least, then we'll recursively unfold all of it and we put the opcode at the end, right? So that it's in postfix position. But if you give me something that's not even, well, I guess if the thing you're mapping over doesn't contain any arrays, then they just come out untouched. Sorry, I'm not explaining myself very well. But basically, the unfolding is being too enthusiastic. Like, we always do this inside a folded expression. And i32.const and 0 and call in direct pass through unfold unchanged because they're just individual atoms. But unfortunately, this looks superficially like a folded expression. And I can see I'm going to have the same problem with param down here, I think. Right. Yeah, so if call indirect appears like as a folded expression, then we know how to deal with this stuff, but we don't know how to deal with it when it's not. This is not a folded expression. Yeah, okay. So, oh God. So I think this might, I'm sorry, I've ended up down a parsing rabbit hole here. Nobody likes, apart from Kevin Newton, nobody likes working on parsers. And I didn't intend for this to happen, but this does actually seem like a fairly fundamental problem with my AST parser, so I'd better deal with it, which is that we need to be able to, I think we need to be able to do the unfolding while we're parsing. Because at the moment, we just unfold the whole thing to begin with before we even start parsing it. And so there's no opportunity. Like, basically, I don't want this to be unfolded. I mean, obviously, I could hack around with this and I could say, well, now let's recognize this as a type of folded expression, and just make unfold not change it. But that's dishonest because this isn't an instruction. This is just an argument to an instruction. Like, that's the instruction, and it's just not right. I'm doing something I shouldn't be trying to do, which is yeah, it was a bodge what I did. What I did was that I defined unfold so that it would recursively descend down the tree. So every time we've got a collection of expressions, we just call unfold on them and then flat map the result and then splat it into the resulting instructions. And that's too crude because that discovers nested lists like this that look like a folded instruction, but it's not appearing in instruction position because call indirect takes, admittedly, an optional, but an extant optional immediate argument. And you can see there's another one that I don't think we've even implemented yet, but this param one also can appear after call indirect. And look, here's one that's got call indirect type proc param result. So we have to be able to, in the same way that when we're parsing code like this, we're incrementally chewing through it. So we pop off block, we pop off i32 const, we pop off call indirect. Like the parser knows where instructions begin. Like we have this parse instruction, and this gets called every time we are trying to parse an instruction. Where does that? Yeah. So this is the way we parse an expression is that we just repeatedly call parse instruction, and parse instruction consumes as much of this input as makes sense for whatever kind of instruction appears next. So this is when what we should be doing is chewing off, allowing parse instruction to chew off the right amount every time, and then only unfold if parse instruction hits a folded instruction in instruction position. So what should be happening here, but isn't because I haven't implemented it properly, is that when we're parsing the body of this block, parse instruction gets this S expression here, and first it chews off i32.const 0. That's fine. It doesn't need to do any unfolding because it's already unfolded. And then it gets call indirect type proc, and that is also fine. It doesn't need to do any unfolding. It is already unfolded. And then that's it. So we don't want unfolding to even get involved at this point. So how am I going to go about this? Well, the answer is incrementally, I think. So the first thing when I was looking for calls to unfold, I think that's the only entry point. Right, so at the moment, this is the problem. At the moment, we just indiscriminately call unfold on every item in the S expression we're given, and then the definition of unfold recursively descends through all sub-expressions, unfolding them. And that is, although I could teach unfold to recognize things like this, no, it's just not right, because it's not an instruction. You shouldn't be able to unfold it. Unfold is defined on folded instructions, so we should only call it when we know that the next thing we're going to read is an instruction, and furthermore that it's a folded one. And we can tell that by, you can tell this is a folded instruction because it begins with an open parenthesis. No other instruction, if you look at, plain instructions do not begin with brackets. So you can see here, like block loop if, unreachable nop bur. So all of these instructions are just English letters. Letters. They're English to me. And it's only folded instructions that begin with an open paren. So I think I'm going to stop doing this. So, now there's going to be a different problem, which is that it doesn't know what to... Right. Block i32 const 0 call indirect. Okay. Yeah, this isn't going to solve it by itself. Because Now what I want to do is make parse instruction be in control of this. So when parse instruction sees an S expression, which here is this guy, okay, yeah, it's looking, sorry, I was confused by the double brackets. It's looking at the first thing in that S expression. So here, the first thing is this. So I'm selecting everything except the outermost square brackets there. So it's just the block with its opening parenthesis. So it's this. That's the first, in fact, the only item in the function body, which is itself a list, right? So the outermost list here is the function body, and then the first thing that appears in it is this nested list that is the S expression for the block. So what I should do is have another case in here that says, like, if it's, maybe that's a weird way of doing it, but like, if it's an array, then we were called because we're ready to parse an instruction, and now you found something that, essentially what we're saying is that syntactically in the original program, there was an opening parenthesis there, which means it's a folded instruction. So this is the right place to, I was going to do it in line, but I can see that I've tried to keep this organized, so I'll try not to make it, now that it's nice and neat, I'll try and, I don't think I already have this. No, I won't have it, because folding is just unfolding was just like a pre-processing step, but I think that it needs to be, how's this going to work? Okay, well, we saw that this was what was next, so we can match that, and we get our folded instruction. Now the problem is that the unfolded instruction, if I call unfold, I mean, this, I'm going to call this unfolded instructions, because this is just a flat list of instructions now. And that's why I said we've got a problem, because we got here via parse instruction, but now we've got multiple instructions to parse. Well, I can think of two ways to do this. One of them would be, I mean, this is really gross, but one of them would be to say unshift that back onto the beginning of the S expression. So having, and this is, remember, this is part of the state of the parser. So this is saying, like, having consumed a folded instruction off the front of the S expression, unfold it into a flat list of instructions, and then whack those all back onto the beginning of the S expression, and then call parse instruction again. So it's going to bounce back to here. I mean, this might then, is this going to happen recursively? No, not at the moment, because unfold, what I'm leading up to here is that I think unfold needs to stop doing that recursive descent thing. It needs to just unfold the current instruction and leave everything else alone, so that unfolding only happens when and if we reach that open parenthesis in instruction position. So that's one way of doing it. It seems a bit disgusting. Right. Okay, so, I mean, it hasn't, I don't think this has made anything worse. I think this is still the same problem that we had before. Yes. Oh, it's slightly different now. But ultimately, the unfolding has caused a problem there. Just going to think about this. I really don't want to do this. Like, I'm trying to. I haven't stated this as an explicit goal, and it's not very important. But I've been thinking about, as I've been working on this parser, I've been thinking about, is it going to be possible to make it so that all of this parsing is just joined together with enumerators? Like, could I have, I don't have a tokenizer at the moment. I've just got that S expression parser. But if I did have a tokenizer, could I have like an enumerator of tokens that's either feeding the S expression parser, or more likely is just directly feeding the AST parser, and the AST parser is just chewing through a stream of tokens. And then everything can be incremental, right? Like, you can be pulling bytes off disk, then you're pulling tokens out of those bytes, and then you're pulling AST nodes out of the tokens, and there's no big upfront cost of building, a huge data structure. You can just, there's sort of a series of coroutines that are all working together to feed instructions to the interpreter, sort of on demand, rather than just like building a huge tree up front or a huge S expression or whatever. I don't know if I'm ever going to do that, because that feels more like a sort of a performance thing than a correctness or clarity thing, and I'm trying to prioritize correctness and clarity. But nonetheless, that is the reason I explain that, is because it makes me pretty uncomfortable that this, firstly, this is just a bit gross to be pushing stuff back into the S, to sort of be modifying that S expression beyond just consuming it. Feels like a real hack. And it would be antithetical to what I just said about, like, basically making it so that the parser is always making forward progress through the input. Like, that's what you actually want. I think the idea of the parser pushing stuff back onto the beginning of the input is a bit grim. How else might I do this, though? I mean, I suppose the obvious temptation here is, okay, look, I'm just going to commit this because I think this is like a unit of thought, even if it's not good. So what have I got uncommitted? Yeah, that's all my... I do need to stash it because I want to try running the test. Okay. So I don't think this has broken anything. It's just... I mean, at the moment, I think this is actually just doing it in the... Hasn't changed very much. It hasn't changed very much. But it creates... Where I'm going with this, and I realize I haven't got there yet, but where I'm going with it is that I want to be able to change unfold so that it doesn't... I already said this, so that it doesn't work recursively. So this is a step towards that. So let's say unfold instructions during parsing, not upfront. During instruction parsing, not upfront. This is the point at which we know for sure that we're about to try to parse a folded instruction. So we'll only try to do unfolding when we know when it's actually appropriate. The problem I'm trying to solve is that expressions like, what is it? It's that flat instruction sequences get messed up by unfolding because the type proc part looks like a folded instruction but isn't. So by only trying to unfold when we know we're in instruction position instead of recursively unfolding everything indiscriminately, we should be able to avoid touching immediate arguments like type proc. To do that correctly, we need more control over when and where unfolding happens, which is what this commit gives us. We still need to change unfold, the unfold method, to leave sub-expressions alone. If any of them are in fact folded instructions, they'll get their turn to be unfolded when they're parsed. Okay. I'm unhappy about the sExpression .unshift situation because I don't think we should be pushing anything back onto the input. I'll think about an alternative shortly. Do I want to think about that now? Maybe. I mean, the short version is that I think the solution here is not to call parse instruction, but instead to call parse expression. Because parse expression the reason I'm pausing is because I'm trying to think about, for want of a better word, what the type signatures of these things are. Parse instruction returns a single instruction. And the good thing about this hack is that I've retained that constraint. Because now parse folded instruction just calls parse instruction. However, inherently, a folded instruction is not just, if we're not going to do this, if we're not going to push stuff back onto the, if we're not going to push stuff back onto the input, I mean, basically, what I'm trying to say is that if here we did like parse, well, let's say like with input sExpression, so this is this helper that allows us to sort of temporarily switch the parser state so that it's focusing on a different, this should be unfolded instructions is what I meant. So I was reading the signature of the method. So if I say like, right, temporarily we're going to focus on whatever that unfolded instruction is, and then in here we basically call parse expressions. I don't know what I need to give that. But basically I call parse expression. I think that's fine, and it doesn't entail shifting stuff back onto the input, because parse expression, the whole point of parse expression is it's got a loop inside it. Oh, I have to provide terminated by. Well, for now, I'm going to do this. I'm going to do that business. I mean, this was just supposed to be a. I'm thinking in code here. So if I do something like that, what happened to my? So if I do something like that, then that effectively solves this problem, because now I think I could just inline this. Oh, no, that's okay. No, I don't like that. I don't like having a local variable called unfolded instructions. I think I'd rather not give that a name if possible. So if we can say, I think this is easy to understand. Excuse me. So we say, with the following input. Oh. Sorry, I don't know where my voice is going. So yeah, with the following input, unfold that folded instruction to give us a flat sequence of atoms. Actually, they're not instructions yet. So yeah, all the more reason to not give it that silly, misleading name. We tack on this sentinel or terminator or whatever you want to call it, so that parse expressions loop knows when to stop. I mean, could we make it so that parse expression just... Oh, it's because of read until. Why do we need to do all of this? Read until terminated by. Right, I mean, there could... This could... Okay, I won't get distracted by this, but this could be finished, or... Because we've got a predicate that tells us if we're at the end. So actually, let me add this to my list. Make read until, and therefore parse expression automatically stop when they reach finished. Is that actually correct? I'm not sure. It might hide syntax errors. I don't know. Okay, well that's... I'm getting distracted now. But okay, so pop the stack a couple. So the problem here, I think this is the right thing, but now this returns whatever parse expression returns, which is an array of instructions, whereas parse instruction is just supposed to return a single instruction. So I think I need to sort of do this. Either I make parse instruction capable of returning multiple instructions, but I'd sort of rather not do that. I'd like to keep parse instruction fairly simple here and hoist that test up into here. So hold on. So this is actually a loop. I wrote it in postfix, but that's the loop. Until finished, shovel parse instruction onto expression. So that's currently what we do. And we were relying on that call to parse instruction, seeing this array and then calling parse folded instruction. But if I want to maintain the sort of type discipline of what does parse instruction return, which I think I do want to, even though Ruby's very forgiving, and I could have parse instruction return multiple instructions, and then I could just, use the kernel array method to sort of coerce them always into an array, and then use concat here and stuff like that. I would rather, because what I'm trying to go for here is like conceptual clarity, I would rather not sweep stuff like that under the rug. I would rather make it, as far as possible, unless it becomes really difficult to do so, I would kind of like to write a program where, apart from when I'm doing those incremental refactorings, where halfway through the refactoring, the types are all a bit weird, I would like it to land in a place where if you did want to go through and put type annotations on this with sorbet or whatever, which I'm not going to do, but in principle, when you're reading the code, I would like for you to be able to go, oh yeah, parse instruction returns an instruction, from the AST, without having to think about, but it could also, in some circumstances, be an array of instructions, and that the caller has to deal with that. I just think that's, although it's not completely intractable, I think it can make it more difficult to understand. So I'm trying to avoid that. So yeah, what was going on down there, case peak, I'm going to do that here instead. So sorry, this is what I was trying to get at, is that now I can call parse folded instruction outside of parse instruction. So this can be like the maybe this could be, who calls parse instruction? Oh, only me. Okay, hold on. I could change the names here. Oh, there's plain and block instruction. Okay, I think what I'm going to do... I'm sorry, I keep changing my mind here. What I'm going to do is... Okay, sorry, I'm going to undo. Sorry, I'm thinking on my feet here. What I want is... I think I'm going to have like a def parse folded instruction. Oh, I already have that. Sorry. And I want this to be like parse unfolded instruction. And then I want to replace parse instruction with that decision. So case peak in blah parse folded instruction else. But that's not right. Sorry, I've changed my mind again. I'm sorry. This is a decisiveness disaster. Just writing that made me realize that the operation we want to do inside this loop is different, depending. What I mean is, okay. Sorry, I just wasted your time. I apologize. This is why it takes me so long to write stuff, is because I really don't know what it is that I want to write until I try to do it. So case peak. So this is what I was worried about. And if I just allowed myself to write the code, I would have realized it quite quickly. That inside this loop, this isn't just expression, shovel, parse folded. Like that's what I was in my head. That's what it was. And I was like, oh, I can just extract this case into parse instruction and then rename parse instruction to parse unfolded instruction or whatever. And then this parse expression will stay really nice. But actually, I think it's important because what this is doing is accumulating the instructions in this for this expression. And actually, because parse folded instruction returns multiple instructions, we have to do concat there. So it's not just choosing a control flow path, it's also choosing, depending on whether we get one or many instructions back, we have to use shovel or concat in order to add it, sort of accumulate it into our list of expressions. I'm sorry, that was very long-winded. Do the test still pass? Yeah, that's looking quite healthy, isn't it? Oh. Staged stack.west. So this is something like return full expression, or let's say return array, return expression, i.e. array of instructions from parse folded instruction. This avoids the need to unshift the unfolded instruction onto the S expression, onto the this avoids the need to push the unfolded instructions back onto the input, because we can just recursively parse the whole folded instruction and return a list of all the instructions we find. However, that does mean that we shouldn't call it from within parse instruction anymore, since that method only returns a single instruction. So the call site has moved into parse expression, where we can control how we handle the return value, i.e. expression concat versus expression shovel. All right, okay. So this has all been sort of moving the furniture around for the change that I actually wanted to make. R's, please. Okay. Right, and the change I actually wanted to make was I've lost my puts, haven't I? That's what happens when you use get restore. Okay, so right, so I've been working up to, for the last, well, hour and a half, I suppose. I've been working up to being able to change how unfold works. So that's what I'm going to do now. So now, at the moment, we haven't actually fixed anything, because the very top level call to unfold that happens within the first time we find, the fact that I'm only calling unfold when we hit this block is very noble and everything, but unfold will still recursively unfold all of the list elements there. So unfold is doing damage. So yeah, basically, I think I just need to go all the way through this and find all of the recursive calls and get rid of them. So this, well, maybe this is going to be easy. I can say all of the places where we're doing flat map, unfold. Sorry, this is supposed to be a replace. So get rid of that. Get rid of that. So that means we're only doing... Oh, I need to go and fix that. We're only doing one level of unfolding, essentially. No ampersand there. So we are still... At the level of the folded instruction, we are still moving, in this case, we're moving the opcode and its immediate argument into postfix position in the list, but we are not touching the rest of the list. And then if that rest of the list does contain any folded instructions, then when we bounce back into the parser, it will end up calling unfold again to unfold those folded expressions. But we're not just doing it unconditionally like we were before. So is that it? There should be no more recursive calls to unfold within the body of unfold. Okay. So hopefully now... Oh, ooh, good. Okay, so it didn't completely fix it, but it has done what I wanted it to do. Hold on, I was supposed to be running this thing. Okay. Cool. So that's not throwing an exception anymore. That was the thing that I wanted to test. So you can see now that because this thing doesn't get recursively unfolded, it only gets unfolded one level deep, and then this never gets unfolded because it's not a folded instruction. So that has achieved what I wanted it to achieve. So I still can't commit the change. This is what I'm trying to get, right? Is this talk about make the change easy and then make the easy change. Like, this is painful, but we're getting there. Actually, is it just... I think I've still got puts in there, haven't I? And then what's the... Okay, yeah, all right. So this change is something like... Well, let's run all the tests while I'm thinking about how to describe it. Situations like this, I'm very glad that I've got so many tests that are exercising this code because it feels a little bit seat of the pants otherwise. So this is something like only unfold the top level of folded, only unfold folded instructions one level deep, something like that. I can't think of a better way of phrasing that. This allows us to only unfold legitimately folded instructions, not immediate arguments that superficially look like they're folded. Any nested folded instructions will themselves get unfolded when the parser reaches them. Okay, so that's good. The tests are all passing. I still haven't broken anything, but clearly we are still not ready. I'm going to remove that stack.was. That's not doing anything anymore. Okay, so the reason I was happy is because, like, this is a much simpler problem. Like, looking at this, you can see that unfolding is now leaving alone these immediate instructions that sort of look like folded instructions, but aren't, because it never reaches them in folded position. So that's great. The problem now is that we don't support the call indirects param argument. It does just occur to me that I think maybe we don't need this anymore, because the whole purpose of this was to support that recursive call. So I think if I get rid of that, sorry. Let me just run the test again. But I think if my understanding's correct, yeah, no, it's straightforwardly the case that now, because we only call unfold when we are at a folded expression, and B, we no longer recursively try to unfold anything inside that expression apart from the top level, we're never gonna hit this case. So yeah, it makes sense that we don't need that anymore. So this is remove unused fall through clause in unfold. We now only ever call unfold, not umlaut, unfold with folded instructions. So we don't need to and the final case is a generic, or is a catch-all for any opcodes not explicitly mentioned, i.e. all the nullary ones. So we no longer need the final fall through for non-folded instructions. Okay, that was a little bit, the commit message was too much longer than the content of the diff. Okay, so yeah, now I just need to deal with I just need to make sure that I actually support all of the syntax, right? Like, so I've added, we discovered there was a problem with labels in structured instructions, and I've added those. We discovered there was a problem with, the type argument should have been optional, but wasn't. And now, well, let's just have a look at this. What am I ultimately going to need to support? Call indirect can be followed by type. Well, it looks like, I mean, as far as this is concerned, it's followed by a single type. Let's just have a look. I don't know why I'm playing this. Guess the syntactic structure from the example code. So call indirect has this optional table. Like this was the thing that tripped me out last time. The table index can be omitted, defaulting to 0. We see in this file that the type use can also be omitted. Like there are plenty of places where it just says call indirect on its own. So I suppose for the type use, it looks like right. A type use may also be replaced entirely by inline parameter and result declarations. In that case, a type index is automatically inserted. So syntactically, I'm not really thinking about the semantics of this, but it's saying that you can have zero or more of these param things and zero or more of these, oh, and here as well. So if, whether you have type or not, so the type is effectively optional, and then you can have zero or more params and then zero or more results. And we can see that here, that this one's got, oh, there was one that had, yeah, 2 params and a result, and this one had a param and 2 results. So it's like an arbitrary 0 or more of each of these, and I can see that param and result have this sort of presumably an arbitrary number of, I think we've dealt with this somewhere else. Have I already got a param? Oh, I bet it's in the, oh, it's in the interpreter, isn't it? Yeah. So we've already, this chunk of the parser that still lives in the interpreter is dealing with this. But now it's going to be, now we need it in here. So this is yet another reason to consolidate these two things, is that now we're going to have to, oh, such a pain. Now we're going to have to support this in both places for at least a while. So effectively what I'm going to do is here, I'm going to, so this is going to have to be a loop. This is going to have to be like while rest in, what comes first? Param. Don't care. That becomes the param. Oh, we're going to need params. And this is just going to say params gets param. And then this whole thing again. Param result. And then the only reason we're doing this is to leave them alone, right? So that's why this whole thing was just, I don't care what is here. It could be empty, as it is in some cases, but I don't need to, at least for the purposes of this, I don't need to care what's in here. I mean, arguably, I didn't need to care what was in here either. But I can't write a pattern match for this because I don't know how long it's going to be. Here, as far as I know, there was a single required argument to type. So I was able to actually constrain it there, whereas here there might be 0 or there might be 10 of these, and there's no way to write that in a Ruby pattern match, so I'm just leaving that as a splat. But the point of doing it is just to preserve them so that we get params results. So that's going to allow, because presumably it was unfolding that was the problem. Oh, maybe not. Oh, well, yeah, it is. So because unfolding doesn't know that this is an immediate argument to call indirect, it actually did swap these around. It treated this as a... It's actually a little bit inconvenient that I've just got a huge catch-all for nullary instructions rather than having a big list of them, but that was just pure laziness. But that laziness is coming to bite me here because it makes it harder to understand what's gone wrong. But what's gone wrong is that this has been unfolded because call indirect didn't consume it. So even though unfold didn't blow up here, it's done the wrong thing. So now hopefully if I run it again, now what I want to see is a parsing error saying I'm trying to parse an instruction called param or something. I32. Oh, it's still doing the wrong thing. What did I... I don't understand what I did wrong. Oh, oh, no, it is. Okay, I misunderstood. Parsing is the problem because it's only consuming call indirect here. It's leaving this behind, and then this immediate argument ends up appearing in instruction position, so it does get unfolded. Okay, so we can't see the fact that it's actually survived hopefully that it's hopefully survived unfolding. Let's just put s expression inspect here so that we can just see. I just want to see it having unfolded it correctly. That's not very insightful, is it? Okay, all right. I think it's okay. I think the problem is that we need to make the same change here. Again, I would love to have a solution to this problem of having to update it in both places. But at the moment, I do not know what that solution would be. So we need to do something similar here. In fact, all we're doing is skipping them because I don't care about them. So this is going to be while the next thing is a param, we're just going to read it. And I'm just doing my usual thing of pushing it through the pattern match. And then this is going to be while peak in result. We just ignore it. So that will hopefully now consume, when we do the call indirect, it's going to consume this stuff as part of the... Okay, well, we got somewhere, but it doesn't seem to be doing anything. Why has it got stuck? I'm sorry, this is a lot of parsing rubbish. Okay, so what is this? If I32 call indirect end. Oh, okay. Right. So I can't actually find the exact one. But it might... Yeah, I'm not sure exactly where this is. But I can see what the problem is, which is that this is a conditional that doesn't have an else. So this is just if, and then it's got a consequent, and then it doesn't have an alternative. Maybe it is this one. But then I'm confused because I thought we'd got down further than that. So this is breaking my brain a little bit. Like, actually, how did we... Oh, no. Okay. Right. This is another problem. Okay, so there's like There's an immediate problem and then a further away problem. The immediate problem is that there's a loop that keeps trying to read until it finds else, and there is no else, and so it can't. So that's the problem. Now, the reason I was sort of, my brain was frozen for a minute trying to understand what the heck was going on here is because I was like, well, but surely this is going to cause the problem. But actually, I think there's all these unfolded ones down here, and I think it's something like this. Because unfolding at least in the case of if, inserts an else, even if there wasn't one. So that's quite naughty. Let's look at the definition of the unfolding operation. Maybe that is actually what it says. Yeah, that is what it says. So actually, it's not naughty. Sorry. I mean, I could leave it out. But the point is that the if has an abbreviation that allows you to leave the else keyword off. So actually, it's not unfolding's fault that it's inserting this, because this is actually the definition of unfolding. So I'm just getting distracted. Do I need compact here anymore? I don't think I do. Oh, no, I do, because label and type can be nil. Okay, sorry. Okay, so I was wrong. There was only one problem. Unfolding is actually doing what it's supposed to, but the thing that's causing the infinite loop is the fact that there is no way for it to... There's that read until that keeps reading until it finds else or whatever. And because you're allowed to leave else out entirely, you're not guaranteed to find one. So I'm 99.9% sure that that's the source of this problem. Yeah, and it just took me a little while to realize why none of these had provoked that problem. It's because when these get unfolded, we do actually insert an else, because that is what the definition of unfolding here says. It says if you've got a conditional, even though this else here is in these metasyntactic parentheses, and then there's a tiny metasyntactic question mark there indicating that the whole thing is optional, the unfolded version of that instruction always has an else in it. So we are inserting it in that case, but when we find these already unfolded ones, it's causing a problem here because it's trying to read else and there is no else. So how am I going to deal with that? So the problem is I did quite a lot of work. Well, I mean, it's fine, right? Sunk cost. But I did quite a lot of work to make it so that when we parse an if, we can... My initial implementation of this read out the body of the structured instruction regardless of whether it was a block or a loop or an if. It was like, read out everything between the opcode and the terminating end. And then I had something called like split on else or something that broke up the body of the if into the consequent and the alternative by finding an else in there somewhere. And then I went off on a big rant about how that was bad. Well, what I did was I did some refactoring so that I could reuse, so that I could do this. So I could just say parse expression terminated by else, parse expression terminated by end, and it would find, instead of reading out the whole body, it would read out the first bit and then the second bit. But unfortunately, you know, I can't do this. Because I don't know that there's necessarily going to be an else there. So I think I probably do need to break it up into 2 stages. I think I need to read out the whole body. Oh, is that right? There's a problem here with the semantics of my... Sorry, I'm not being articulate. Parse expression throws away the terminator. So I don't know whether it's been terminated by an else or an end. Because if I go to read the consequent and it turns out it's terminated by an end, let's say that I make it possible to specify multiple, you know, let's say that here instead of just saying else, I can say else or end, and it'll allow it to be terminated by either of those things. Okay, that's great. But parse expression uses read until, and read until just throws away, you know, we read every atom, and if it is the terminator, then we just stop. So it's already been thrown away at that point, sort of by design. So that means that I then don't know whether I still need to read the alternative or not, because I don't know what we found at this point. So, okay. I think this could probably be improved, because maybe what I need to do is to refactor the way this stuff works. It's just really awkward because it's already got a return value, right? Like, I want to read the consequent. The reason why I made read until throw that thing away is because you never want it. You don't want, when you read the consequent out, or when you read the body out of a loop, you don't want to get the end token at the end of it. You don't care about that. You just want everything up until that thing. I mean, I guess maybe I could leave it in the input. It could be a peek rather than a read. There's just so many calls to it. All of these would have to... I'd have to change all of these to manually throw away the terminator, and that just feels like too much of a pain. So instead of doing that, what I'm going to do is I'm just going to read out the body for all of these, which is great because they all need it anyway. And then I just need to think about what that means in terms of getting the consequent and the alternative out of the body, basically. Okay, so assuming that I've read the body of the structured instruction here, and then this is taking care of the label after the end, fine. Now I have to do something special in the case of if. Oh, okay, well what I need to do is say with input, body, do, and then, so at the moment I'm just reorganizing the code. I'm not trying to change how it behaves. So we're still gonna parse terminated by else. There's a label after the else, or potentially, so we have to keep that code. We're not going to need this thing that deletes that reads the label after the end is already taken care of up here. But now this, yeah, this is another situation where this needs to have like a little terminator on the end, and then this needs to be terminated by end of input. So again, we're sort of switching, or sort of pushing a new input into the parser, onto the parser stack, if you like. We're saying now we're parsing the body of this structured instruction. And now we're using the end of that body to terminate the alternative. So I need to say end of input equals object.new here. Okay, so does that... Oh, hold on. Sorry, I've got ahead of myself. I should have committed this, shouldn't I? Ugh. No. I did not mean to press whatever that was. Okay. Yeah, I'm sorry I got overexcited because I had some more test failures. Okay, so assuming that all passes, which it has. So this is I did a whole thing here. Support optional immediate arguments for the call indirect instruction. So I can take that to the bank. That's fine. Okay, and then now so this is the intention that, yeah, it's just structured differently. Rather than, I don't know why I put a new line in there. Do I want that there? Yeah, maybe I do like that. So now we're reading the body once, and then we get the consequent and the alternative by back to where I started with this, splitting up the body on else. Okay, let's run the tests. Okay, that's looking hopeful. So this is something like read consequent and alternative from the body of the if instruction. This will make it possible for, this is a step towards making else optional. I think that, that's just a motivation for it, because otherwise it seems like a very strange change to have made to that code. Oh no, why? Parse normal instruction else. Why has that happened? I'm a little bit superstitious about the scope of these local variables inside this block, so I'm just gonna, let's just make sure that Ruby's got the scope right, because if it's just because they're inside this block, then I'm not interested. No, okay. Parse normal instruction else. So this is in float expras. Okay. No fold LTF. Okay, how does this work? I don't understand why that's not working. I mean, what happens to if? Is that also broken? Yeah, okay, right. I've just broken it. Okay, this breaks right at the beginning, so hopefully there's a simple explanation. Invoke empty. If local get then. If local get then else. Alright, so let's have a look at let's see what we're getting out of this. Oh, it's not even getting that far. Parse normal instruction. Oh, should this just be... Oh, hold on. I can't do this. I can't say parse expression here. That's where it's going wrong. It's because it's trying to parse the whole body of the conditional as a single expression. That's not right. That's not right. So what I did here, my clever attempt to hoist this up to the top level is misguided. We can't do that. This has to be... This has to be read until. Like, this is... I don't want it to be parsed yet. It'll be parsed here. Let's call this input. You know... Or like body S expression or something. You know, it's not a well-formed expression. That's why those tests are blowing up, is because that else that's, I mean, that was, sorry, the thing that gave me the clue was the fact that this was complaining about else. And I'm like, well, why are you trying to parse else? And the answer is because I was trying to parse the whole body. but you can't. We've just got to read in the body. And then I think we can still do this. But then we have to do that. Let's see. I32. Okay, so hold on. What's the actual diff here? What? Right, so I've forgotten I'd actually committed this. That was a bit premature, wasn't it? Okay, so we read up until the end, and then we so what's the problem with that? I don't understand why that's going wrong. This is annoying. It's annoying to be working on this. Like, parsing is never the fun part. And if I just used some kind of parser generator, I wouldn't be having to do any of this. Oh. What the hell? Oh, is if not one of the ones that we support. Oh no. Okay, I'm sorry. That was very silly of me. I should have been checking float expras. Okay. I thought I was losing my mind for a second there. Okay, right. Okay. So at the very least, that commit is now correct. But now that doesn't solve the problem. It's just refactored it into a shape where it's possible for me to solve the problem, right? So I think the code that I want to be able to write is, like I said before, I want for it to be possible for this parse expression to be terminated by either else or end. Oh, I guess it's not end, actually. It's end of input, because that is what's at the end. And then for this alternative here, well, yes, because this special sentinel or whatever object at the end is going to have been removed if it was found by this parse expression. So here I need to be able to tell the difference between if we're finished, which means if the S expression is empty, then the alternative is just nothing, else it's this. Because bearing in mind, consequent and alternative are just lists of instructions. So here the alternative is no instructions, and here it is whatever is left unconsumed. So that's the code I want to be able to write, and the only problem is I can't write that because I don't think parse expression will accept, multiple terminators. So let's have a look at that. Parse expression doesn't care, it just passes them on to read until. So maybe in here I can say, for some reason I'm more comfortable with the idea of being able to support one or multiple as this input. I don't know why it's not consistent with the opinion I expressed before. But in here we can just say terminators equals array terminated by, because if you say array 1, you get an array containing 1, and if you say array 1, 2, 3, you get an array containing 1, 2, 3. So that sort of coerce it into an array. And then instead of saying opcode equals terminated by, I can just say terminators include opcode. Okay, so that still works. It feels like there are 2 commits there. There's that one, which is something like support multiple terminators in read until, like in that film. And then the rest of it is, well, I suppose this is just support optional else in if. In the if instruction. Yes. So now, oh, what's the big whoop? What had I done in my stash? Oh, this is just. Yeah, I don't care about that. Oh, that was, okay, yeah. Right, this is the commit that I'm eventually going to be able to land. Okay, that's this. That's this. Okay. I could have just run stack, but I want to see what happens. Okay. Fantastic. Great, so that actually is my whip commit. And then I can delete that tag. Great. Authored at 8:21, committed at 10:21. So that took me almost exactly 2 hours to make the change easy. And then finally we make the easy change. Okay, great. Well, I'm sorry it took me 2 hours to get that working. It's not necessarily the most impressive 2 hours of video on YouTube. at least now. Well, what can I say? Oh, right. Okay, here's the payoff, right? Is that now, hopefully, that's made the parsing faster. The test run faster. Okay, so let's switch back to the upstream branch. I have to say it's detached. And let's time this. I mean, obviously, I'm streaming video as well. Yeah, thank you, Chris. You are quite right. Chris has just said, did that make running tests any faster? It's been, because it's taken me 2 hours to do it, I'd forgotten why I was doing it. Okay, so total runtime, 20.76 seconds. Okay, so now let's switch back and let's run them again. What we're looking for is something faster than 20.76 seconds. Suspense is killing me. I mean, it's a bit faster. It's a couple of seconds faster. I mean, that's a bit disappointing, isn't it? My suspicion is that if we run that call, there we go, 2.92. 0.41. So that's, I've gained a huge percentage on running that one specific test, but actually I'm a little bit disappointed. That's only saved a couple of seconds overall in the test suite. But that being said, in my defense, I wasn't, I suppose I was doing it for performance reasons, but the other reason why I was doing it is because it was wrong. Like, it wasn't right to be parsing. I mean, okay, I'll take the win. Thank you, Chris. It's a couple of seconds faster. Hooray! It worked. But, you know, all the way through this, what I'm trying to do is implement this in a principled way. And the principle of the thing is that it was wrong to be parsing the function body here. In fact, you know, I was talking about separating out, maybe this is what I'll do next actually, is to retroactively justify what I just did. Maybe what I'll do is separate out the parsing stuff from here, because, you know, this is all parsing, and now the body gets parsed inside this chunk of parsing code. So now if I want to do surgery and move this out into AST parser, which the more I talk about it, the more I think I do, this will come with it. You know, instead of this being AST parser.new.parse, it will just be parse, because it will be already inside the parser. Like, that's exactly the thing that I want to happen. Whereas invoke function is never going to move into the parser, because this is pure evaluation. So I think that was worth doing. Oh, I mean, the reason it took me 2 hours is because it flushed out loads of stuff that was broken with the parser. So I think it was worth doing, even though I feel like I'm protesting too much in explaining why I bothered doing something that gives such a naff performance improvement. Okay, well, I haven't, you know, annoyingly, I ticked this 2 hours ago when it wasn't really done. So I've just reticked it, so that's okay. In doing this, have I inadvertently done? I mean, look, there's a little bit unfold and parse together. I sort of am doing that now, but not in the way that this is talking about. This is saying somehow make it a single operation so that you don't have to double up all the work. Oh, look, fix the problem that the if abbreviation, which allows the else to be optional, only works for folded expressions at the moment because we reinsert the else during unfolding, but it applies to unfolded expressions too. Okay, clearly at some point in the past, I realized this was going to be a problem, and I thought it should be fixed, and now it is fixed. Great. Okay, so... Now, I know this is turning into a bit of a joke now that I still haven't introduced the identifier context, but actually I think probably finishing, I am in an uncomfortable intermediate state at the moment with respect to parsing, because I did all of that work to extract the AST parser from the interpreter, but it's not finished. I've only extracted the AST parser for expressions. I haven't extracted the AST parser for modules and function definitions, and memory and tables and globals, types, and all this stuff. These sort of commands or actions or whatever they're called: invoke, assert, return. I mean, those aren't really part of WebAssembly, but they still need to be parsed into some kind of AST. Well, they don't have to be, but I don't really want. I mean, maybe I could nibble that off first. Maybe I could nibble off the. Maybe I could just do the module parsing first and then worry about invoke and assert return and stuff later on. But it's annoying because they still do, they still have parsing in them. But maybe that would be a way to do it incrementally, would be to try and bite off parsing a module, for example, move that into the AST parser, and then think about these other bits and pieces. Yeah, I think I am going to do that, because this is just a ticking time bomb of stuff that's in the wrong place. Like, this really shouldn't be here. Or at least most of it shouldn't be here. As always, I already did that. I already did the monologue about having this sort of complected lump of code and then staging the computation by pulling it apart and having the connective tissue between them. I need to do that again here. The connective tissue being some new AST nodes that are produced by the AST parser that drive whatever pieces of functionality there are in here. I mean, for example, this memory command here, or whatever it is, whatever the right word for it is, instruction, I don't know. This thing here that actually creates some memory, that really is evaluation. So instantiating the memory here from a string should be in this file, but I would say that this bit inside the parens that actually parses the strings out of the S expression probably shouldn't be in the interpreter. That big lump of data should just be in an AST node ready for the memory to be hydrated from it. So it's not just going to be a wholesale move of this code into the AST parser. It's going to be a, disentangling the transporter accident type situation, and have the AST nodes like communicate the essential information from one place to the other. So I think that's probably as it was when I did it for expressions. It's going to be a little bit laborious, I'm afraid, but I think it's got to be done. How do I want to approach this? Obviously, I want to approach it incrementally. I think what I'm going to do is make an entry point in the parser. Because at the moment there's just this parse, which is actually rather bad. This should be parse expression. But parse expression is all the way down here. Who calls parse expression? Oh yeah, but this is the one that takes all of these private methods, all these private parse methods don't take the S expression as argument, because they're just using the state of the parser. And this is because this is like a public entry point. It does take an S expression and store it in the state. Oh, I haven't thought about this. Anyway, I want to have a similar thing here that's called like parse script for parsing a complete one of these, Like that's ultimately what I want, is I want to take a complete file like this, run it through the S expression parser to get an S expression, and then run it through parse script to get an AST. And I think maybe ultimately this method will go away as a result of that, because then this will become the entry point. Although whether it's useful to still expose this, I'm not sure. It occurs to me actually that maybe I could, sorry, let me stash that for a second. Oh. Just thinking about naming things. Maybe if I rename parse expression to parse instructions, because that's what it does. It parses multiple instructions, which is what we call, which is what the word expression means. But effectively, you'd expect to have one of these parse things for each sort of production in the grammar, and in a recursive descent parser. And here it sort of says, there's this production that says an expression is multiple instructions. So actually there is a little bit of a formal justification for saying, let's have this entry point be parse expression, and then it can call through to parse instructions. I think that's okay. Oh, I don't want to time it anymore. That's too depressing. Okay. So let's do that. And then that makes room for that. I was a little bit uncomfortable about having those. It was fine when there's just a single entry point. To just call it parse is like, okay. But I wasn't very comfortable with having parse and then parse script as the two public entry points, because it's like, well, what does that mean? So this is rename AST parser parse expression to parse instructions. This is a private method, so it doesn't really matter what we call it. But by not calling it parse expression, we free up that name for reuse by the public method currently called parse. The point of this is to make space for a second public method called parse script. All right, well now, nobody inside here calls this. It's only, I mean, I believe that's true. Yes. And I think the only caller of this is in here. Oh. I'm wrong. Well, all of these need to be parse expression now. Not that one. Nope. Yes, 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 yes. Okay, so there were a few callers. Right, but the reason why there are all those callers is because we don't parse, we don't try to parse this S expression, so we're repeatedly calling into the AST parser in all of these places where we're encountering expressions. But really, we should just parse that whole thing to begin with. Let me just see some tests run. Undefined method parse expression. Okay, I just hadn't saved it apparently. Okay, that's convincing. rename AST parser parse to parse expression. Fine. And now we can do the thing that I was trying to do, which is have a sort of a sibling method called parse script. To begin with, I'm just going to have this do nothing because I just want to wire it up. So, as I was saying, the way I want this to work is that we parse the S expression and then we get an AST by getting the AST parser and parsing the script, giving it the S expression, and then the interpreter will interpret that script by giving it the AST. Now, right now, interpret script is expecting to get an S expression, and indeed it will, because parse script doesn't do anything. But by plumbing it in like this, this gives me a place where I can start making changes inside parse script, and as long as the interpreter, you know, in this case here, if I decided that I'm going to make it so that I actually can parse modules and I return a module AST node, then in here, instead of looking for a module, this could be like in module, you know, functions, tables, globals, or whatever. And I can leave the rest of this alone. So this is, as you know, returning to a recurrent theme of this project, I'm going to keep cutting over more and more of this incrementally, but first I want to get it plumbed in. So I'll let this just run for a second. Okay, this is looking hopeful. Cool. So wire up interpreter to AST parser parse script. This doesn't do anything yet. I'm going to implement it incrementally. Okay, so what I actually want to do here, yeah, okay. So I think this is the same as what happened when I did the expression stuff, which is that there's a sort of a tree of functions that get called here, right? Like we start out by calling interpret script at the top here. And then we descend into one of these cases. And then, well, I mean, what I want to do is start by converting module. That thing I was just saying, I want this to be something like in module functions, whatever. But before I can do that, I need to deal with all of these bits and pieces that appear inside here. Like, you know, before I can have an AST node that represents a module which contains several functions, several tables, and several globals, I need AST nodes to represent each of those things. And the way that I get those is that I have to be able to parse functions and memory and so on. And I just don't have those yet. So I think that here, instead of calling define function, well, inside define function, I mean, this is just all parsing, isn't it? Just trying to think about how I want to play this. I want to make changes that aren't going to break anything. So I'm just thinking about like, I can't think of a good way to cut this one over rather than instead of just moving it wholesale. Because I don't want the problem is I don't want to make AST nodes for all of this nonsense. I don't want to turn this list of expressions into something that's just gonna into a load of nodes that's then going to be interpreted by this loop. Like this loop is the parser. So I think essentially this whole method here just needs to move into AST parser. I mean, maybe that's the way to do it. Maybe I just move it. Is that enough? Maybe it is. Because the reason I'm saying that is because this doesn't have any downstream. This doesn't call anything else. This is self-contained. I mean, it calls parse expression, but that's fine. That is in the AST parser. So like this defined function is like a leaf of the tree, I suppose. So if I just prune this off and plop this into here, I mean, let's call it parse function. I mean, right now this needs to be public because I'm going to call it from here. So this is going to become AST parser dot new dot parse function. But ultimately, once I've moved all of this code over, all of that code is going to live in parse script, and then I can make this private. But for right now, as I'm cutting over, this needs to be public so that it can call across the boundary. I'm just trying to think. No, there's no straightforward way for me to move. I can't just move interpret script like that. But I think parse function, it's okay to move because everything that this is doing is just building up. It's just building up this. I mean, these things are all just AST nodes, these locals and parameters. Like this is a little AST representing the function. So I've kind of already written this over here. Let me change this. In addition to changing the name, let's change the name of the argument, and it's no longer a keyword. So does that still work? No. Expressions each do. Oh, this is optional. So this needs to, firstly, this needs to be, we're modifying S expression here, and then this needs to be S expression. Okay, I think that's it. It was running the test that I wanted to do again. Oh, right. Okay. Okay, hold on. So before I can move that code over, we need to move over parameter, local. Is it just parameter and local? Oh, and function. So all three of these can live in AST, and I think that just gets included anyway. Yeah. So I don't think that's going to break anything. Yeah, so see, that's fine. So that's just move parameter, local, and function into AST namespace. They're basically AST nodes already. They were just being parsed, being produced by the parser that's stuck in the interpreter. Okay, so now that I've moved that over, it should be able to see those classes now. Yeah, there we go. Okay. So let's just say move interpreter parse define function to AST parser parse function. This was already basically a parser method, so it just needed moving over to the right place. The only thing that occurs to me about this is that it's written in a different style, right? When I moved things over, I had to do changes like this. Destructively consume S expression in blah. Destructively consume S expression in blah. Let's have a look at one of these. Maybe this one. So it sort of did this conversion from repeatedly matching it against something that was like a head and a tail to something that was actually somewhere here shifting stuff off the front. This was before we had these helper methods for doing this, finished, peek, and read. But this code is written in a different style, and I should really update it to work in the new style. But I think what I'm going to do is just move everything, do the separation first, and then I need to do another pass through at the end to sort of update it to use the different style. So maybe I'll say that here. It's written in the wrong style. Instead of destructuring an array into a head and tail, so repeatedly destructing an array into a head and tail, into its head and tail, it should be storing the S expression in the parser's state and using the helpers to destructively consume it. I'm going to wait until all the parsing methods are extracted from the interpreter before I convert all of them to this style. just because I think the chances of me losing the will to live are significantly higher if I try and do that at the same time. I think if I can extract stuff and get the win of that stuff living in a different class, then that gives me a nice stable stepping stone to be standing on to say, like, right, I've made it halfway across the river, and now I just need to go through and do a boring mechanical transformation of this code to make it work in a different style. Okay, so what else is holding me back here? I guess I'm just going to need to work my way through this. Like, if I can work my way through all of this stuff in module, then by the time I get to the end of it, I'll be able to make parse module. And then if I can do all these other things, then I'll finally be able to do parse script. So I suppose what I'm trying to do here is replace all of this memory. Well, let me just paste that over here, and then I'm going to think about what I want that to look like. So let's assume I have a parse memory. So obviously that is not yet usable. What would I want to get from that? So let's say here, memory. This is like several cases there. So let's say I can do this. Memory equals astparser.new.parse memory expressions. Okay. And then there are some different cases that I can be in here. Assuming I've got an AST node that tells me everything about what was in here. I mean, maybe there are two different kinds of AST node, because there's like memory from data and memory from like size. But just to keep it simple, I'll say, like, imagine that I can call memory.string and memory.minimum size and memory.maximum size. So that's my, well, let's just make it. I don't need to hypothesize about that. String minimum size, maximum size. So let's imagine we have that, and I'm conscious that that's clashing with the existing. We already have a class called memory that's defined here, but in this file, this one is going to win. So adding it to the AST namespace is not going to interfere, but it is going to allow the AST parser to be able to eventually return a, memory.new string minimum size, maximum size. So assuming I've implemented that already, it's like, what do I want to do here? It's like, if there's no string, again, this is not necessarily the best way to communicate this in the AST, but for now, let's just say there's one type of thing here, and it's just a record that's filled in with either it's got a string or it's got a minimum and maximum size. So if there's no string, then we're in this situation. So we're saying the minimum size and the maximum size, well, those are already on. Yeah, and we'll have already done the interpret integer business and stuff because that's part of parsing. So yeah, and this is just memory, minimum size. This is memory dot maximum size. Okay, I mean that's a bit horrendous, isn't it? Something like that. Oh, I can probably hoist this outside the conditional, can't I? Because I'm only going to have, well, what I'm going to have here is memory from string. String is memory.string. I think that's right. And there were two different cases in here for whether there's a minimum and a maximum size or just a minimum size. But if there's no maximum size, then the default is just nil. And so I'll just, in the parsing, I'll just arrange for the maximum size to be nil to preserve that behavior. So I think that's the code I want to be able to write, is something like that. But that's predicated. So this is the evaluation part of it, right? Is like assuming that I've got all of the information about the memory. This is how I actually create it. And I hate that this is an instance variable, but I'm just gonna not get distracted by gross stuff from the past. So in order to make that work, I have to have something on this side that is able to actually do this thing, right? It's going to be case s expression. When I call this, it doesn't include, for whatever reason, I mean, again, this might be a mistake, that actually maybe I should be passing in, instead of passing in the contents of this s expression after the initial opcode, maybe I should be including the initial opcode, but at the moment I'm not. So whereas previously it was matching this thing, and now it's going to be that thing. So it's going to look, well, what happened there? Oh, right. I was overzealous, because actually that is supposed to look like that. Because this is one of these immediate arguments that's got a structure. Sorry. So something like this. So now instead of instantiating anything, I just need to assign these local variables, string, maximum size, minimum size. So I'm not making an instance of @memory there. I just want to assign a local variable so that this can pick up the value of that. Similarly here. And similarly here. So I think that's the relevant part of it. I can see that there are bits missing, but let's let the tests. Oh, hold on. What? Oh, have I just not hit anything that's using memory yet? Probably. Okay. Float memory. That's an ideal way of testing this. Okay, parse string. Do you mean parse script? I do not. So here's a method. Who is calling this? Oh, nobody. Okay, so this was the only caller of parse string. So I will have that. That can come with me. That doesn't seem to call anything else. That's just a little helper. I'm just going to pile all... No, that's because that can be private. That can be private. I'll stick it down here with parse float and parse integer because these look like they're doing that sort of business, don't they? Great. Is that everything? Sort of looks like it, doesn't it? I wasn't expecting that to be so... Oh. It's not so. Expras. Interpret integer. Right. Oh, yes. Okay. So do I already have that here? Well, that's the one I just pasted in. But don't I have a parse integer? Oh, right. But this... Okay, well, the short version is... Well, so this is just a copy. Parse integer is a copy of interpret integer. I assume someone else is using interpret integer, it's not just me. Oh no, that is also just me. So that can also move over. See, this is great. We're taking all kinds of junk out of this parser, of the interpreter now. So I've already got parse integer here, so I can just call parse integer. But unfortunately, parse integer doesn't take an argument. It reads from the S expression. And that's because of this, the style mismatch that I was talking about before. This is intended to be called from methods that are destructively consuming the S expression and therefore don't need to pass it in as an argument because it's stored in the parser state. But I am not doing that yet. Well, I can think of two ways around that. One of them is to add an optional argument to parse integer temporarily that allows me to pass in a string. And the other one is to use with input. Does that work? Because that's arguably the neatest way of doing that. Because with input just assigns, it's like all this, that's all that it does. It assigns its input as the current S expression. And then when I call parse integer, it will use it. So, I mean, that's a bit gross, but I think it's probably fine. And it will come out in the wash when I convert the style of this, because then this whole thing will, this S expression will be in the parser state, and we won't be calling parse memory from over in the interpreter. We'll be calling it from inside parse module or whatever, which already will have assigned the S expression and so on. So this is just a temporary fix. And really parse string should do the same, shouldn't it? Like if I'm going to be consistent with this, I should fix this so that this works with input parse string. And then that way I won't forget to sort it out later. So this needs to be nullery. And then read into the string. Yeah, that's how parse float works. As discussed, it's how parse integer works. I think this is right. Maybe not. Undefined method shift for 1. Oh, it needs to be, this needs to be a fake S expression. It needs to be a fake S expression like that. Okay. And this also needs to be. I don't really like doing this, but I think it's okay to have some extra junk here to correct the impedance mismatch between these two styles. And what I would rather do is, as far as possible, do stuff in the style that I want it to be, which is like this, and then rather than have, I don't really want a mishmash. I don't really want parse string to take a string, but parse integer doesn't take one. It's too messy. So I'm going to try and keep these helpers consistent, and then these big picture functions are just going to have to be cleaned up later, I think. So let's see. That's looking good. My ability to type is not looking so good. Okay, so there's definitely more than one change here, right? I'm just thinking about what order I want to communicate these changes in. Well, let's say add come on. Add AST memory. What have I normally said in here? Oh, actually, I've tended to fold the AST. I've tended to fold the AST node in with the. So is this actually an instruction? Like if I go to text format, modules, memories. So this isn't so much an instruction, this is a memory definition. So I think maybe in keeping with all of these other commits, maybe it would be like parse the memory definition. Something like that. But I, of course, meant to add in these things. I mean, maybe this whole thing... I'm going to take a different tack. I'm just going to say extract AST parser, parse memory from interpreter, from the interpreter. The extracted code in parse memory was the only client of parse string and interpret integer, so they can be moved over with it. I've adapted, so they can be removed from the interpreter. I just realized interpret integer wasn't moved at all. I've adapted parse string to look for its string in the parser state, even though that requires some fixing up, some temporary fixing up in parse memory, because the latter doesn't use the parser state yet. But that's okay, I'll come back to that later. I didn't put that in my commit message. I don't think anyone needs to read that. Okay, so I'm just gonna continue in this vein. Feel free to fall asleep now if you're not finding this especially gripping, but I'm just gonna keep chipping away at this, because you know, you can see once this whole thing has gone AST parser flavor, then this, you know, I'm sort of starting at the leaves and working my way up. I'm not doing a very good mime of it, but starting down at the leaf nodes, converting those so that they produce AST nodes, and then once that's done, I'll be able to go up a level and say, well, let's just make an AST node for the whole module, and there'll be a parse module function that does that. Okay, so in a similar vein, that is going to become parse table S expression. I can already see that that's going to need the table AST node. So again, that is just an AST node, but it was in the wrong place. So let's move it over. Move table into AST namespace. I don't think anything needs to be said about that. So this again is going to be some kind of in table expressions. Tables gets AST parser.new.parse table expressions. I think that's the only code that we need there, because previously that's all it was doing, was creating this effectively an AST node and then adding it to this array. So that's all we need to do there. And now we just need to make this work. What's it going to do? Well, essentially all of these occurrences of rest, I think that is S expression. So I think here I can just say it's not the most beautiful thing. But again, I think this will be fairly easy for me to clean up, you know, make it destructive. I think that should be it. That should work, right? Oh, except for that bit. You know, like this. I'm sort of trying to make these vaguely consistent. Well, that one isn't. Actually, looking at this, why have I got that hash instead of just local variables? I think I'm going to go back and change that because that's silly. I don't know why I decided that a hash is better than local variables there, but for some reason I did. Yeah, I'd rather keep all of these stylistically consistent if I can. Let's see if that works. Let's try stack.wast because I know that uses tables. Yeah. Okay. So again, what's my extract AST parser parse table from the interpreter? So yeah, while I remember, let's just change this. Basically get rid of all this tapping and all that nonsense. And say that function, well, maybe I can just say exported name, parameters. Well, in fact, it's only these ones that need to be initialized. Parameters, results, locals, body equals 4 empty arrays. And then in here, anywhere that we see function, I think this. No. Do I need to escape more things? How do patterns work in Vim? Okay. Does the star need to be escaped? Does the dot need to be escaped? Do the square brackets need to be escaped? Yes. They do. Okay. All right. I could have done it by now. Okay, so you've got to escape the square brackets because otherwise they mean a character group. And yet you have to escape the brackets to make them meaningful. What a pain. Who designed that? Oh, I forgot about underscore. Okay, well done. You got me, Vim. Okay, right. So now this becomes yeah, I like this more. Okay. Exported name. Right. So that needs to be initialized to nil because it's inside a block. Otherwise, the scope of that local variable is not sufficiently wide. Okay, I think I like that better. Use local variables instead of hash in, what is it, parse function. Damn. Unhandled exception. What have I done wrong? Name, exported name, parameters, results, locals, body. I don't understand what I've done wrong there. What on earth has changed about the semantics of this? Is it that name isn't nil? No. What's the unhandled exception? Oh, it's the function's got the wrong name. Oh, it's because of this. Previously, all of these. Oh. It's because of these uses of name. They're clobbering that local variable previously. Right, it wasn't a local variable before, it was an entry in the hash, so that's why this wasn't a problem before. So this needs to be like this. That's not very nice, is it? I think that's all of it, though. Yeah. I think perhaps I don't need the exported name anymore. No, I'm wrong. Yeah, I guess I need that there to force the scope of that local to be outside of that block. So that's fair enough. So I just moved it so that it's immediately after the introduction of that function rather than it being disconnected. Okay, so what was I actually doing? Right. So I did consequence and alternate. I was just remembering that I did that there. Was that necessary? I think it was, because otherwise I think the... Yeah. Yeah, it was necessary. Okay. Sorry, I just got distracted by that thought. Okay. Sorry, I'm focusing now. It's just this parser stuff is really boring. I'm sorry. So that's not what to say to make it gripping content, right? Okay. Right, folks. Now we are going to continue the exciting task of extracting parser methods. Oops. So this comes over here, and this is going to be parse global. What do we want this to say? In global, we're gonna say globals. Okay, so globals here is like a special data structure that's got pairs of... that's got name value pairs, because that's what we need them to be inside the interpreter. But I think probably what we should do is say parse global. So like that gives me an AST node, and I think we'll want that to have global.name and global.value, because you can see that's what comes out of that. And then, right, we've got to evaluate something. But now we should arrange that the value here has already been parsed. So here we should just be able to say global.value. So I don't want to do any parsing here beyond parsing the global. And now in that AST node, global.name will be a string, global.value will be an expression that I can evaluate. And then having evaluated it, we pop it off the stack, and then this just needs to be globals.name. So I think that's right. And then we're going to need an AST node for that, with just a name and a value. And then in here, this becomes like, this is S expression, has to match that. That's currently the only shape that we understand. Except not this, because that's already, so it's just the rest of it, the name and then the mutability. I'm sure this is going to have to change over time, but right now this is the only shape of global that we've seen in the tests that are passing. So we don't want to do any evaluation. That doesn't belong here. And this AST parser.new we don't need, because we can just call parse expression directly. We don't have a stack. We're not interested in making any. So this is just going to be global.new name value, I think. Maybe I'll extract this so that it's in a similar shape to the previous one. like that. So yeah, we always have the big chunk of gnarly code where we assign all of the locals, and then the line at the end that just calls the constructor and uses hash punning to provide all of the necessary keywords. Globals.name. Yes, you are quite right. I cannot type. Okay, that's looking hopeful so far. Okay, extract AST parser, parse global. All right, looking good. Now this type doesn't do anything, so I guess we're done. And what I mean by that is that now I can just take this whole thing and that becomes parse module. So let's put that further up because I feel like it. Well, let me be a little bit more persuasive than that. Because I feel like we want to have the big things at the top and then, you know, their dependencies below, basically. The entry points are right at the top of this file, and then I want you to be able to sort of jump down to the callees of those things. I'm conscious we're not using parse script yet, but at some point we're going to fill this in, and we're just, now what we're doing is sort of building our way up to it. Okay, so I'll start by thinking about, I mean, this is the way that that always makes sense to me, is like think about how I would like to be able to use it, and then that will help me to think about it. So assuming that we've got this, what do I want to be able to do here? The problem is there is some interpreting in here, isn't there? You know, the creating of the memory and so on. So I think what I'm going to have to say is, I can't have a local called module. Put underscore on the end. So let's assume that I've got this sort of AST node. So what's this going to have? When we iterate through all the expressions, we're populating functions, memory, tables, and global. So I think probably globals. So I think we probably want an AST node for module that has those things in it. So it's going to have functions, memory, tables, and globals. So assuming we've received that, what we need to do is sort of dispatch each of them. Like, what do we do with it's functions. Functions, memory, tables, globals. So if we've actually got one of those in our hand, what do we do with it? I'm just going to copy this because I keep forgetting what's in it. Okay, so functions, ultimately that just needs to be assigned to self.functions, so we can just do that. That's annoying, isn't it? Memory's a bit more difficult. Tables, we can just do. Sorry, I've spelled functions wrong again. And globals is a little bit more difficult. The reason I'm saying they're more difficult is that they need a bit of processing. So it's like assign memory from module.memory, and then this is assign globals from module.globals. So I think we can probably just take this. And so this is basically what we had before, but instead of saying memory equals blah, now it's just going to be module.memory. And then all of that code still applies. Tables we've already dealt with. And I think this is just going to be that. And we ignore the whole type situation. So again, this is going to be oh, hold on, this is not that simple. For memory, there's only one of them. For this, there are. So can we say self.globals? That's right, right? That's what we used to do, is assign self.globals. Yes. So we're going to assign this to module.globals.map, this thing. I think that's right. So that's just iterating over all of them and doing what we did before. So this is sort of a bit of a mixed bag. Like some of them we can just pull out directly because we just need to remember the AST for the functions and the tables, because they really are just information that we're looking up. Whereas the memory, I mean, I guess the same is true of the globals. Like, why is it important? Well, I guess for one thing, I have to evaluate them. Those AST nodes contain expressions. And yeah, this is really just, this self.globals is really just another kind of memory, because we need to be able to both read and write these. So that makes sense. Okay, well, if that's the code I want to write, then how do I set this up so that it works properly? So case S expression in that. Do nothing, I guess. In that. So it feels like this loop is essential. And also having an end at the end is essential. I don't think we need to do any of that. These are all going to turn into, I guess once again, we're going to need, the idea here is that at the end we're going to have module.new functions, memory, tables, globals, and then I think again I'm going to need to nil these out at the beginning so that they have the right scope. So functions, memory, tables, globals is no functions, nil memory, empty table, empty globals. This case seems relevant. Like all of this parsing is actually just what I want. So in here, that's exactly what I want. This time I just want to call parse function, which does still take an argument because I haven't converted it over yet because it's one of these old style ones. So that can stay as it is. I mean, these will all work as is because I've literally copied them over from somewhere that they work. So similarly here, so I parse the memory. That's it, isn't it? All of that stuff stays in the interpreter. And I think this just becomes globals. Add parse global onto it. So I've just got to hold on to all of these AST nodes and pass them back in the module definition. So let's see what happens. Nothing good. Because I spelled module wrong. Undefined method string for nil. That's because this should be module, not memory. Oh no, it shouldn't. What's gone wrong here? It looks like memory hasn't been assigned. Is that okay? I think it is okay because previously this piece of code only got activated if we did find a memory instruction or whatever. But here, there'll always be... Well, here we're just doing it unconditionally. So I think I have to say unless memory is nil. I think I have to guard this because most modules don't have a memory definition in them. All the rest of these are arrays, so they're going to be empty by default. But this probably doesn't want to be. This probably should be an array. It's just that, well, I actually don't know if you can have more than one memory, but we certainly haven't seen it yet. So, okay, that's looking hopeful. What would the commit message be if I were to write one? Module. Let's just let that run through, but that's looking pretty hopeful to me. I mean, none of this is incredibly beautiful, but I think that's actually pretty cool. So now, as promised, all of the stuff left inside here is just evaluation concerns. So it's setting up the memory. I mean, it occurs to me now that these didn't have to necessarily to be segregated by type. Like I could have just had an array of definitions and we could have just iterated over them. I just assumed it would be easier to segregate them by type. And I think it probably is. So I'm going to leave it that way. I think it's okay for the parser to have to do lots of work iterating over things and switching on, comparing to strings or comparing against types or whatever. But in this case, I think it's fine for us to just say, well, a module has got some structure. It's got 0 or more functions, 0 or more tables, an optional memory, 0 or more globals, and those things are stored separately and we can just dip into all 4 of them and sort of vivify that module definition to make... I mean, makes me realize that actually all of the stuff I'm storing on self here, I really should just be storing an object that represents a module. And at the moment, it's broken up into these 4 different pieces, but actually a module does contain function and table definitions and a sort of vivified memory and some globals that have been brought to life, and that should all be wrapped up in a nice little module object. So I think maybe I'll, I mean, this is just turning into a to-do list. Introduce a nice module object in the interpreter to wrap up the function and table definitions and memory and globals state. Right. But I'm not going to do that right now because I'm going to carry on. And what carrying on means is getting invoke converted. So I will put that after parse module. Okay. Oh, actually, look, a lot of this is not relevant. Oh, I just realized I missed this. That's the important bit. But it's just a name and some arguments. So really, this should be, on this end, it should be something like, I'm trying to regularize this a bit. So invoke equals astparser.new.parse invoke expressions. Let's go around again. Would have been quicker to type it. And then this here just becomes functions.detect function exported name equals invoke.name. If function nil, complain about these things. Invoke.name. Evaluate. That should all already be parsed. So this should be invoke.arguments. And then we call invoke function as before. So assuming that we've already got this parse invoke, then function equals functions detect. Right. So we just need invoke to have a name and parsed arguments. So this is really quite mechanical, isn't it? S expression matches that. Name and arguments. Don't care about that. Don't care about any of that. This is going to be invoke.new name arguments, and we just need to make sure that the arguments have been parsed. I think we can just do that. In fact, I think we have to do that because it's just a sequence of instructions that you have to execute. Looks good. Oh, except how on earth? I was going to say, I haven't got an invoke. It's like, why hasn't that blown up yet? Invoke equals, it's because this is actually quite rare. invoke doesn't show up until later. It's mainly assert return that contains like a nested invoke. Name arguments. Okay, let's float memory. Okay, that looks fine. Okay. That is looking okay. The tests have all passed. All right, onward. Right, assert return. This is the last one. Yeah, I mean, it's really long, but it is the last one. So it's that whole thing and this. Parse assert return, I suppose. Okay, so all of that. What we're going to say here is in assert return anything. I suppose we're just gonna go for it. So what going for it means is that we're gonna parse it. So that's that bit. Oh yeah, so same as above. So what should an assert return look like? It's got a nested invoke, and then it's got a load of expecteds. So I think maybe we can just represent that as, you know, assert return dot new invoke expecteds. So let's stick that in the AST. Okay. So that's what we're going to do here. Well, that's what we're going to have. So this here, where I'm comparing it to name, that's actually going to be assert return dot invoke dot name, and then if function nil puts, and this name needs to be assert return invoke dot name. Again, not very beautiful, but it'll do the trick. So I think that's it. That's just the error reporting. This needs to be, so now this is assert return dot invoke dot arguments. I mean, there's clearly something that can be extracted here, because this is just interpret invoke, basically, that has been implemented twice. Invoke function. Oh yeah, it's a local. So this is invoke expecteds dot length, raise unless stack empty, invoke dot expecteds dot zip actual values, case expected. Oh crap. Okay, I'm not sure what to do there. Else, let's comment all of that out because I need to come back and think about that. So this is the case where we're using this special syntax to check for a canonical or an arithmetic nan. I think we just need an AST node to represent that, but I'm just going to do the easy bit first and then come back to that. So I think all of this looks okay, except this is going to have to... Expected will already have been parsed, so that's already it. If we haven't identified that it's one of these weird nan expectations, then it's just an expression for us to evaluate. And then we print out this stuff. I think I copied too much stuff when I looked at this before. Oh no, I didn't. Okay, right. Yes. Right, because of this zipping, we don't want to print a dot for every pairwise couple of values. We only want to print one dot at the end, so that makes sense. What do I want to do here? If we did have a sort of nan expectation AST node, that could be inserted at this point, then that would allow me to take this branch of the conditional. So we need to know how many bits it is. And we also need to know, in fact, yeah, there are a couple of things we need to know. We need to know this string that says whether it's canonical or arithmetic, because that's what is used in the expected value here that shows up in the error message. And we also need to know how many bits it is. So this is all parsing stuff. So that stuff will live in the parser. Bits is already a local variable. We've already got actual value. Success equals float.nan. So I think all that original code is fine. We can just leave it there. But now I have to do this side of it, which is a bit of a slog. So S expression goes into that. Invoke name arguments. Oh, I suppose I suppose here at least, to deal with the name and arguments, I can just parse invoke. So actually, if I just make this invoke, and then I can reassign that. Quicker to type it. Something like that. So rather than, I don't need all the details of that because it'll be handled by this match up here. That's the beauty of recursive descent parsing, isn't it? I don't need to care about looking up the function because that's evaluation. Oh, I do need to... Right, so I've dealt with invoke, so now I've got to deal with expecteds. So I suppose the temptation is to say expecteds equals expecteds.map parse expression expected, well, _1. But that's not going to work. So that's all evaluation. I just need to set up expected so that it's ready for this loop. But it's going to need this. It's going to need this conditional inside it. Like I can't just do this. Let's be grown-ups about these variable names. So we don't need to worry about actual values. I don't need to worry about success. That's never been a problem for me. Don't need to worry about dots. But we do need to... Yeah, so like this is the else case, I guess, is just parse it. But this is the case I'm worried about. So if we do match this thing, don't care about the expected value. I do care about the bits because we need that. The interpreter will make the format. I mean, there's no reason why I couldn't make the format here actually, but let's let the interpreter do that. Maybe it would be nice to have that in the AST, but for now I'm just going to punt that because it's not parsing really. I certainly don't have the float, so I don't need any of that. I just need to make my nan expectation here. The nan and the bits, and then that's what I need on the other end. Nan and bits. Hold on, I lost something here. What's that? Where did the nan go? It used to say expected value equals nan, and I lost that somehow. In nan expectation, nan bits, expected value equals nan. Yes. Okay, I think that's all correct. Okay, so I actually have to provide nan and bits here. But otherwise, I think that's okay. So if we find one of these strange expectations, so i.e. something that's not an expression that we can just evaluate, then we're going to have a special node to indicate that, and then on the other end, we know how to deal with it. So I think that's okay. I think that's the best solution I can think of to that weirdness. Oh, I've got some kind of syntax error, which isn't good. Oh yes, look. So that needs to be assert return invoke. Yeah, annoyingly, because there's a local variable already in scope, that it thought I was referring to that. Oh, hold on. Invoke is not even the right thing there. That should... It shouldn't be invoke at all. That's correct, I think. try again. Yes. Okay. So this is parse assert return. Okay, I feel like we're nearly there. Because now I'm at the end of this. I'm at the end of this business. So all of the branches of this case have now been folded up to the point where we've got AST nodes for all of them. So I think this whole thing probably essentially the whole body of this thing I think this is right. I think, well, let me try and sketch it out. I want to implement parse script, basically. And then on this side, all right, so this is already plumbed in, right? I maybe could have left this until the end, but for some reason I decided to. We're already calling parse script here. So what you get in interpret script, which should really be called evaluate script, is an AST node. Like, if this returns script.new, on the assumption that we're going to have this, it's obviously going to need some fields. And those fields are probably modules. Well, no, because these are just commands, right? Like, what does a so if we look in interpreter, the README, it talks about this. Scripts. The S expression format is interpreters is a very simple notion of script with commands as follows. So commands are module, action is something like invoke, assertion is something like assert return. So these are all commands. So this is going to need commands. So this is going to be script.commands.each do, and we're going to iterate over all of that. But yeah, rather than like S expressions, they're going to be AST nodes. Certainly don't need those. What am I doing? What file am I in? Okay, sorry, I was getting confused. This needs to be script.commands.each. Okay, look, I shouldn't be working on both of these at the same time. This needs to be S expressions. sExpression.each. Oh yeah, it's already called commands here. Okay. So which side am I going to work through first? I suppose this side is the most sensible one, because that's what's I'm getting confused. I keep jumping back and forth. But here, this is going to be script.new commands ultimately. I assume we're going to need to retain this. I don't think PrettyPrint is going to be able to deal with those commands anymore. Oh, in fact, it will be fine because it will just return it if it's not an array. So I'll deal with that later. Okay, what goes in here? Case command. It's not going to be this anymore. It's going to be in module, functions, tables, memory. What's the last thing? Globals. Oh, so we don't need this local variable called module underscore anymore. That's nice. So these just get matched in the pattern. That's already come out of the pattern. Unless memory, no. Right, okay, so all of these local variable assignments are making this code nice and easy, I think. And then we just need to get rid of that. Globals.map. Okay, so that doesn't change very much. Here we're going to say in invoke, and I think that's just got a name and arguments. Yeah, we've been given that. We don't need to say invoke dot anymore. Just say name, function nil. That doesn't need to be invoke dot name anymore. Oops. Just evaluate arguments. That's very nice. So that's nice and easy. In assert return, oh, that's got an invoke, and it's got expected. In fact, this invoke is going to be an instance of invoke, so we can do this. That's wrong. So this can be quite similar. We don't need that. We've already got it. So that can just be name again. I mean, this is literally just a copy of what's above. It's just arguments. That's just expecteds. Expecteds.zip. I think that's all probably unchanged. Yeah, looks like it. That was only referencing stuff that was local to the block. Same goes for that. Okay, so we've got a sort of catch-all case here. What do I want to call that? Like, I need an AST node to communicate this idea because it prints out a dot but the assertion is being skipped because we don't support it yet. So I'll just make that skipped assertion. I'll need to put that in the AST. So if we encounter a skipped assertion, then we'll just print a dot to indicate that it's been skipped. So I think I'm just going to read through this to make sure there's no obvious oversights, that there are no obvious oversights. Okay, that all looks okay to me. So I suppose now it's just a question of making the other end of it work correctly. But I think it's going to be fairly simple, because really all of the work here is all the evaluation stuff. So I definitely don't need to do that. I don't need the begin, rescue, end. I mean, this is just going to be a map, isn't it? Because each case here is going to yield, in this case, I just need to parse the module. I think that's it. So it's just going to be for each of these, making sure that I return the right kind of AST node. I think that must be right. Because this is just dispatching to the right parser that we've already implemented. So if it's one of these guys, then then we just make a new skipped assertion. So if we've mapped over all of those, I mean, because this one's a map, I guess I'll do this. So I think that's it. I think we can do parse script from, well, which we're already doing over here. And then that passes the AST into interpret script. Nope. Why doesn't it like that? Syntax error, unexpected label. Have I just got the syntax wrong for when you've got those nested? Oh, maybe it needs a key. Yes, okay. That is the value of invoke. Yeah, okay. Does it think that's a local variable? Yes, it probably does. Oh, this is a big mess. This is why this needs to be separated out into multiple. Yeah, I think if I break these out into separate methods, then you won't get that sort of local variable leakage. But it's definitely a risk when the method gets that long. Okay, this is looking good. I mean, you can see that we've lost basically all of the benefits of the S expression parser being incremental, because now we've got to wait for the whole AST to be built before the test starts running. So that thing I had before where the green dot started appearing sooner because it was sort of streaming in S expressions from the file and executing them one at a time, that is now no longer the case. But I think it's worth it to have a much better factored interpreter. Okay, so I guess this is extract parse script, even though it was already there. I mean, that was really the extraction. Okay, so I'm starting to get a bit sleepy. I mean, I'm conscious that I haven't really... I've ended up just wallowing in the mess of parsing for pretty much this whole time. Oh, I guess all of these can be made private now. So all of that stuff. Yeah, I think I'm just gonna like put this up here. So let's say make all script parsing methods except parse script private. So let's say now that parse script is working, we can there's nobody is calling any of the other methods from outside of the class. Yeah, now that the entry point is working, nobody is calling any of them. Okay, that was a pleasingly small diff. Right. Okay. Am I awake enough to continue doing this? I think I probably am. I don't like the naming of this stuff because we've got similar kind of deal here where like this is called evaluate, and yet the thing that evaluates the yeah, that should just be called, I think this should just be called evaluate script. Yeah, okay, and that's just the public entry point for that. And now that we've done that, I think this evaluate method should be a little bit more specific, because this isn't for evaluating anything, it's for evaluating an expression. So evaluate instruction takes an instruction, evaluate expression takes an expression, and evaluate script takes a script. But those are all ASTs thereof. So let's replace evaluate with evaluate expression. Yep. 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 Not too bad. So this is just evaluate to evaluate expression, assuming that those tests all pass. Okay, good. I like it. So I'm just trying to work out if I've got the energy for this, but I think I just want to get it done. Which is to convert this to work like this. So whereas for the conversion, when I was extracting things, I was sort of extracting from the bottom up, because it was easy to move the leaves out and just patch in calls to them until the very root could be moved over, and then all those patched in calls were then like local within the class because everything had been moved over. Here, because it's a dependency on what the current state of the receiver is, and what I'm talking about is this business. You know, sticking an S expression. I mean, I don't know if I need the end of input, but just something like this, right? Where I'm sticking an S expression on self. I can make this change here, and none of my callees have to know about it as long as I pass in the right thing. So I think in this case, I need to change the root, and then I can move down to the next level and make it so that parse module doesn't take an argument anymore. Instead, it just uses self.s expression, and then propagate that all the way down until we're done. In fact, this self.s expression equals s expression thing is a bit silly, because that's what with input does. So really, that's the nice way of doing this. So actually, this should be that as well. So this should be with input. Do. Let me just run that and check that it's working. Yeah, because that's how that should work. I mean, it also makes it possible to call this from somewhere else. I mean, I don't think we do. Oh, we do. At the moment, we do. Okay, well, in that case, I definitely need this, because by the time parse invoke is getting its argument from the current state of the parser, we can't call up to parse expression and have it clobber the value of that. Although at that point, I'm not sure. Yeah, maybe I do want to call parse expression at that point. Anyway, I'll work that out when I come to it. But okay, that's interesting. Okay, so that's parsing. Use with input in AST parser, parse expression. Well, let's say set input, set current S expression with, that's what it's for, plus it allows us to safely call this method from within any other methods in the class, because with input restores the old value of self.sExpression when it's finished. Okay. So if I do this with input do, and then that, what I'm talking about here is sort of converting it to using these helpers. So instead of just mapping over the current S expression, I guess I'd do something like, just trying to think about how I'd want this to work. Basically, I want a loop here that says until I'm finished. I mean, this bit's going to need to come outside the loop. So I'm going to have to accumulate commands inside this loop. So start with, I mean, maybe this can go right outside, because the whole purpose of this thing is to say, take that script as the current S expression, and then go around in a loop. And then it's not going to be this map. It's going to be something like, we're going to read the command, and then we're going to look at what we got. Okay. I mean, I might be losing my mind here. But what I had in mind was that when we've read the command, then we can use that command as input to the parser. I realize the rabbit hole's getting quite deep here. But now I can say, like, read in the opcode, and then this is case opcode. What I'm trying to get to is a point where what's left in the S expression is the thing that this needs to be S expression. Oh, that's the name of the argument. So I guess this is going to need to be self S expression. Like, because I'm trying to keep all the callees unaware. So I want something like this where it's like we read a whole command and then we dive into that command and say, right, I'm going to read the opcode, I'm going to switch on it, and then I'm going to call down to these other guys. And what do I do with the return value here? Something like that. I'm just trying to avoid indenting it, basically. I'm not sure that's worth it. Maybe I should just do this. And then if this offends me, I could extract a method to do it. This could be parse command. Maybe it should be. Let's see if that works. No. Parse module, parse invoke. Oh, undefined method empty for enumerator. Oh, okay. Well, that's because sExpression parser returns an enumerator. I think maybe this has stopped being useful now, because what I'd need to do is to force that. I'd have to call entries here to make that work, I think, and just collapse it down to an array. Yeah. So I just don't think that's particularly... I think maybe I need to just remove that for now. Okay, just a sec. And then I think there was a... Yeah, here there's a recursive call to parse expressions. So I think maybe that's the more honest. Hold on, what's going on? 20, undefined local variable. Expressions. Oh yeah, sorry. This needs to be expressions. It's kind of nice to be able to yield stuff rather than accumulate it into an array, but I think the reality is that it wasn't actually doing anything because of the way that I can always come back to this. But for now, I think it's definitely less complicated to have this just return, just return an array. So it's essentially reverting this, isn't it? That would have been easier to just do that. Oh, and that. So it's these two. This might be, I might be being too aggressive in taking this out, but it's easy enough to, I can revert this commit, so it's fine. Stop returning enumerator from sExpression parser parse. So let's say we can't make use of this at the moment because the AST parser expects to get an array. It's a shame to stop doing this, but there's really no point in having an enumerator from this method until we can make actual use of it, rather than just flattening it out, rather than just immediately flattening it out into an array. This reverts blah and blah. So I can easily enough follow that back through history, and I can easily enough revert this one if I decide I want it back. Let's just say I may well want this behavior back at some point, but if so, I can just revert this commit. Until then, I won't need to think about whether I'm dealing with an array or an... Maybe enumerator should just be... because I'm not uppercasing array there. It's a shame to lose the incremental parsing. Okay, so now I think that has unblocked this change. I mean, that has made... I'm a little bit... I would hesitate to say anxious, but I'm just conscious of the fact that it makes this a little bit more complicated. It's definitely more deeply nested and maybe a bit harder to understand. But it's how all this stuff works, using read and peek to pull in one, well, at the moment, one sExpression at a time. I mean, ultimately, I can imagine wiring this up so it was just pulling in tokens, but at the moment, it's just pulling in sExpressions. So I think holistically, it's more confusing if it doesn't work that way. Even if the price is, it's not as easy. It's not precisely as easy as it could be to understand. Okay, well, I'm just going to investigate this and see. So this is destructively consume S expression in parse script. Is that what I said before? Yeah. So like I'm already sort of committed to this in the mechanics of the parser. Why is this until finished? I mean, this could be parse commands, couldn't it? In the same way as this is parse instructions. Could that work like that? How does parse instructions look? With input, square brackets tap. Oops. So maybe I could do the same thing here. Oh yeah, okay, that's not too bad. I mean, it's pretty nesty. And then this could be parse command, right? So I think this is not as bad actually. It was the reason it was so nested is because I was in fact this belongs in here. So it's making me think here that there should be sort of an expression .new instructions situation going on up there, but I don't think that's... Would that be helpful? Maybe. I'm not sure. I'm just going to leave that alone for now. Well, I'll leave the comment there. No, I won't. I'll make a note of it. So you call parse script, you give it an S expression. With that input, we parse commands, and then we return a script that wraps them up. Because and script is, we really don't need an AST node for that either. It's really just an array in the same way that the expression is. If not, should we get rid of script, since that's basically the same thing for commands. Yeah, I think it needs to be one way or the other, right? Like at the moment, we're in a bit of a sort of split between two ways of doing it. That's parse script, parse commands, parse command. We read the command. Is it important that we have with input here? I think it is, because we need to refer to the remaining input here, because these callees are not compatible yet. We have to pass in the S expression. Oh, in fact, this doesn't need to be self anymore, which is a nice thing about extracting this. And does this still work? Looks like it. So these can both be. Parse module. Parse invoke. Parse assert return. Parse function. Parse memory. Parse table. Parse global. I guess I'll stick these at the end. Oh no, I want them to be above. Module invoke assert return. Okay, yeah, I'll stick them here then. We sort of have to call through these to get to parse module and parse invoke and so on. Okay, I think that's a little bit nicer. Extract AST parser. Parse commands and parse command. This just makes parse script a bit more manageable. Okay. So, wow, this has been a long session with not, I mean, I haven't even thought about making a test parse. I mean, I guess what I did was that I broke some tests and then I fixed them again by fixing latent bugs that I found in my parser. How far down can I push this? Because really what I want is for all of these private methods, and there are a lot of them, well, not unfold, but the rest of these, to just be able to use the S expression on the parser state. I'm going to start chipping away at them and see how far I can get. So for example, parse module. Does that still work? Because it's just using, yeah, it's just calling through to self S expression. So what is this? This is case peak. And it's saying if it starts with binary. func, no matching pattern error. This is a similar sort of thing up here where I need to read these sort of module directives. Yeah, so if this is else, then we can say until finished. Sort of read into definition. And then I think we have to do something like we did up here with sort of with input definition do. And then inside there, we can do read into opcode, and then this becomes case opcode. And then we lose all of these. And then these will just... And then I think this is this expression. Let's see. Yeah, that seems to work. I think this is what I want. I mean, it feels slightly lower level than what I had before, but I think this is what everything else in the AST parser looks like. So I've sort of, when I was more awake than I am now, this is sort of what I've committed to, is to make it work like this, so that I'm just chewing through one S expression at a time and holding on to that. Yeah, I think this is the crucial thing, is that I'm trying to get away from having to thread the S expression through. I'm just trying to get to the point where I'm destructively consuming it, so that I'm not passing it around everywhere. You just call these side effectful functions and they consume as much of the current S expression as possible. And I think that that is a worthwhile goal, even though it feels a little bit like... I mean, it's not that much different. It's not that much worse. It's just slightly more obfuscated, because you don't get to match against this sort of little array. But this wasn't really... This whole thing is... There's a lot of boilerplate and it's misleading, whereas I think now it's starting to be somewhat boiled down to its essence. So hold on. What method am I changing here? Parse module. Destructively consume S expression in parse module. wonder whether we really need the whole terminated by situation. Because you can set with input to be as much or as little of the as the input as you want. Do we really need terminated by in AST parser? It seems like you can just use with input to set the input to as much or as little of the input as you actually want. Or is the problem finding how much you want? Can read until always just do that for you, rather than baking this feature into e.g. parse instructions? Yeah, there feels like a bit of an impedance mismatch there that I haven't thought about. But I think maybe in all of these other places, we just say parse whatever, and then we just keep going until finished. And then there's this weird exception here where we're having to tell it where to stop. That's not to say you don't need read until, because you do. But I think maybe it can be decoupled from... I don't think it needs to be part of with input. Like you can just do it outside, because that's what I'm doing everywhere else. I'm not actually. I'm assuming that when we're asked to parse a script, we're going all the way to the end. And I'll probably just continue in that vein. Anyway, yeah, I think I'm onto something with this. I think this does sound coherent to me. But anyway, so where did I get to? It's very hard to stay motivated on this because it's really very dull. I mean, exciting. Okay, so that was parse module. Right, so I was working my way through these. I'm trying to go from the top down, so let's do breadth first rather than descending into parse module. Yeah, the temptation was to try and extract some kind of parse definition here, but it doesn't really make sense because of the way that I've decided to segregate all these different types of thing. I need to be able to stick them into the right local variables, so I think it's better in line actually, at least as it stands. Okay, so parse invoke. What's this going to do? Read into name. Parse expression arguments. Is it really that? Right. So this needs to become a with input invoke. So this, again, it's just patching up. This is like what I was having to do elsewhere. To sort of paper over that impedance mismatch. Undefined method plus for nil class. it's this parse expression arguments. That's clearly not right. So what I really want to do is just call parse instructions. Can I just plug S expression in there? That's pretty grim. Yeah, I think I need to untangle all of this. My gut feeling is that these top level methods probably shouldn't be being called from inside, because the whole point of these is that this is where you inject the thing that's going to become the parser state, right? But internally, we shouldn't be calling parse expression. We should be calling parse instructions. But because of the terminated with nonsense, it's too inconvenient to do that. So I guess I'll use it. I guess I'll do this. But that was actually pretty easy. Destructively consume S expression in parse invoke. Okay. Because parse expression will destructively consume its argument, so that's okay. It feels weird, but it's just gonna reassign the same value. So it adds this onto the end of it. I just don't think that's right. Maybe I just don't know. I don't know what to do there. I'm just going to leave it like that for now. I mean, the tests are all passing, so how bad can it be? Probably quite bad. Okay, so the next one was parse assert return. Oh yeah, I mean, presumably this is going to be the problem. Because I need it to actually consume enough stuff Okay, hold on. I think this is going to be really problematic. I think I need to be able to do that, really. Yeah, okay, it just never finishes. So, okay. So what would happen if I were to make it who calls parse instructions? A few a few places, quite a lot of places, if instead of saying what it's terminated by, we just always made it terminated by the end, and then you just have to wrap it in with input to get the effect that you want. So instead of the effect being inside parse instructions, you have to arrange okay. So now we just say with input s expression, parse instructions. This loops until finished. That's fine. See, look, we're already here. The end is what we meant. So that's fine. We can get rid of that. Parse instructions terminated by end. So what we really mean there is with input, read until terminated by end, parse instructions. I think that's what we mean. Or rather, that's equivalent, because previously what we were doing was calling with input read until terminated by. So we're just pushing that out of the call. So this is exactly the same. And now this is now more similar than it was, because this is saying read until terminated by end, but we don't call parse instructions until later. So here with input that. So this is the same thing. Consequent equals, I mean, obviously this is a mess. With input, read until terminated by blah, do parse instructions. Oh, so just read until. So actually, I think maybe we do need an end of input here to make this work. Because you have to give read until some information about what when to stop. I mean, maybe read until should, automatically stop when it reaches finished, but I just need to think about whether that's what I actually want. But actually, I think that probably is okay. But for now, I'm gonna allow this to sort of stand in. So this is going to be else end of input. And then alternative is a similar kind of deal. But this one's just terminated by end of input. Okay. Okay. Did that actually work? Yes. I think so. So this definitely puts more power in the hands of the caller, and I think that's good. Because you can compose these. Like previously, the idea of having an argument on parse instructions seemed like a good one, but actually you need to be able to plug together with input, read until, with potentially any other parse command in order to control how much is getting parsed, I think. So let's say move terminated by outside of parse instructions. This means that the caller needs to compose with input and possibly well, it is that they do need to. If they want to control how much of the input can be read. But that's good because it means we can use the same compositional strategy everywhere, including for different parser methods, rather than having the parse instructions method be somehow special. It isn't. So let's just think about read until. If I say break if finished, or terminators include opcode, can I just completely get rid of all of this rubbish now? So this would just be terminated by else. And that would just be not anything, because with input read until terminated by end of input is just the rest of the input. And that's definitely simpler. If that works, I think that is an improvement. Even if it means that there might be a syntax error that creeps through. But I'm not sure that, I mean, it's no different than what I was doing before. It doesn't make a meaningful difference, I don't think. Okay. Well, that seems to work, doesn't it? So let's just do that for now, because that's also simpler, and it means that we don't have that. It's less code to write. In fact, can I now get rid of this conditional altogether? Because now parse instructions should just return the empty array, because it just goes until finished. I mean, if that works, then that's great. I mean, this parser is becoming a little more technical to operate, but I think it's becoming more predictable in what it does, and there's less wonkiness. Yeah, I really like that. I really like that we've got rid of end of input entirely and just baked it into read until. And actually that means that we don't need yeah. I think I'll just stick all that in one commit and say like yeah, just make make read until stop when finished. This dramatically simplifies things. We don't need to support multiple terminators anymore, like in that film. We don't need to support multiple terminators anymore. We don't need to add special end of input values, and we can just call parse instructions unconditionally and get an empty array back if there aren't any. Yeah, I really like that. I'm glad I took that little digression. So parse assert return. Right, but the point here was that, hold on, stash that. The point is that I should be able to call parse instructions here. Because it's kind of important. It's important that parse invoke actually consumes. I mean, I guess that would have happened anyway now that I'm not modifying the S expression here. I guess it would consume it, but this is more honest, I think. I just want the instructions. I think all these places where I'm calling parse expression, well, maybe not all, some. I mean, you know, having this return an expression object in the same way as this returns a script object would really sharpen the senses there, because it would help me to think about whether I want a single AST node that represents an expression. But here, Yeah, I'm really not sure what I want here. But I definitely don't want to assign a new S expression. I want to keep going. So it makes sense to call parse instructions here. Call parse instructions in parse invoke to use the current S expression. Okay. So now finally I can carry on, because I felt like I'd hit a problem there where I wasn't going to be able to trust parse invoke to consume the right amount of the input. So how does this work? I haven't really understood how this works, have I? So if I read, I'll get this. So read into invoke, splat invoke. Invoke equals with input invoke parse invoke. Now, I guess what I thought actually wasn't really a problem. Because we're using with input here anyway, so yeah, because it's inside an S expression here. I'm not sure what should be happening here, because I'm not doing that anywhere else. Yeah, hold on. What do I want to do here? With input, read, do, read into invoke, parse invoke. Is that right? And then where does expecteds come from? Expecteds is just the rest. So does that work? No. Undefined. Okay, well, something's clearly gone wrong there. Okay, I need to think a little bit more carefully about this. How does this work? Okay, so look, I don't need to pass that in. So that should be fine, because that's the same. Oh yeah, okay. No, what I did was just wrong. Okay, yeah, I can see that now. Because this is a splat. So I don't want to just read it. So I think what I did initially was probably fine. With input read do, read goes into invoke. Parse invoke. So I think that's probably okay. And this will come out in the wash. This is what I was saying about it's a bit weird that parse invoke doesn't parse the invoke keyword at the beginning. Well, everything doesn't parse the beginning. So there's a lot of this in places that it doesn't belong. So I think all of these reading your own opcode things needs to be pushed into the parsing methods. Push all the read your own opcode code inside each parsing method. Let's just say e.g. read invoke should be inside parse invoke, not its caller. Okay, so we read this first thing. We read invoke, then we call parse invoke, and that deals with the rest of it. So yeah, it's a bit weird that it's split between the two, but such is life. And then what happens if I just say expecteds equals s expression? Because it should be everything that's left. Does that work? I'm just trying to make incremental progress here. Yeah, that does work. So let's lock that in. So let's say this is work in progress. Destructively consume s expression in parse assert return. Expected equals. Yeah, so this is this is one of these until finished situations, isn't it? Expecteds is empty, and then until finish, we're gonna try to populate them. Right. What's the right thing to do here? Is it just read into expected? No. I guess. I just forgot to add it to the... Yeah, I suppose that's fine. We're just pulling an S expression off and then we're just matching it against. Yeah, I mean, that seems fine. Fine. That works all right. How much more of this is there to go? I really don't want to roll this over to another stream because it's so uninteresting and I want to do something interesting next time. So I think parse command is done. Right, so now we've got to go down to the next level of depth, which is parse function, parse memory, parse table, parse global, but then that's it. So it's just those four. So let's just do it. All right. Parse function. Okay, so this is if peak in that, then read through this into name. Okay. Oh yeah, okay, so this is one of the things where it's going to modify something different each time. Oh, it's really helpful to keep the original. No, it's not that useful actually. It was the S expression is just the rest. Until finished, read into expression. And then I think this is with input expression do. Whoa. Read into opcode. So read into opcode, and then we're just going to go through and deal with all of these. So read into exported name. So we have to deal with sugar. There's two different param cases here. So this is in param. I've got to deal with these separately. Types. So I think this is parse. What instructions? I'm not sure about that. No. Is this like until finished? Results onto something like that. Like we're just going to keep concatenating those. Two cases for locals there. Oh. This is a bit tricky. So if what we've got is one of these special expressions, then we want to handle it in a special way. Otherwise, we just want to do basically this. But the problem is we've already read the opcode. So this actually needs to be peak. And then all of these have to consume their... That's a bit annoying. Because otherwise it'll be missing. Maybe this should all just be opcode. So I don't have to repeat it. Oh look. I could have... that still says astparser.new. Okay, are we getting somewhere here? This is the trickiest one I've converted so far. So until we finished, read an expression, look at that expression to check its opcode. If its opcode matches export, param, resort, or local, then do something special. Otherwise, just chuck everything that you've chuck everything into the body. No, that's not right. It's not right to chuck everything into the body. You want to... It has to be... damn. It needs to be inside an array. what we add on to the body needs to be inside an array. So it has to be like x equals that. Something like that. Because it's not until the very end that we're ready to parse those bits, but we have to keep them segregated. Because here we've stepped into a list. Is that right? I might be too stupid to do this. Let's see. So what's going on here? I'm pretty much getting too sleepy to be able to do this, but I'm just really determined to not leave it in this broken state. I know, I mean, my current commit is fine, but I feel like I made a decent run at this and now I've just lost all momentum. Okay, if peak in that, then we're doing this, else we're doing that. So we're reading through this to get parameter name. And we're reading again to throw away whatever that dud parameter at the end is. And then we're doing that. Here we don't know how many there are. Basically, whenever there's a splat, we have to do until finished. Read, because we're just throwing those types away. Parameters added on to parameter new, name nil. We're just ignoring the type there. And this looks like it's probably quite similar. Let's see. We're looking, so this becomes a local name, and then something we don't care about. This becomes locals, local name, local, else, until finished. We read all the types, and for each one, we make a new locals with no name. I mean, it'll be a flipping miracle if that works. I don't think it is going to work. Holy shit. Oh my goodness, I was not expecting that. Okay. Well, let's let it run to the end before I get too excited. Well, there you go. Peak undefined method first for F64 const string line 121. And this is my old friend Tau. I bet that if I look in float expros, F64 const is the very first. So we've got to cope with the situation when that is not an array. So case expression in it's an array. We do all this. Otherwise, we just add that to the body. Yes. I'm just laughing in disbelief that that code I wrote actually worked. Such an unpleasant task, this. But it's nearly done. And then I won't have to look at this anymore. This artisanally crafted parser is probably going to have to go in the bin at some point to be replaced by something more principled than this. But right now I'm just, again, this is something that I should pull this apart into smaller methods. So here with input expression do why can't this just be body expression? Because I haven't actually read anything at this point. I've only peeked. So is that okay? Yeah, what I was doing before was a bit of a weird non sequitur, I think. Or rather, I was like making an empty array and just shoveling everything out of one onto the other, which is silly. With input expression. Do I really need to do that? Yeah, well, I need to do it when I get to the until finished. Let me commit this just because it's working. Did I get rid of that whip? Yeah. Oh, I did it in the editor. I did it in Vim. Parse function. So I'm putting this whole thing inside a with input do. But I don't know that I really need to. Certainly for that last one, I don't need to. It's just the ones that that want to use until finished, I think. Because that's the only thing that matters. Like here, where it's like, I'm just going to read the opcode and then I'm going to read the exported name. I'm just going to read the parameter name. Here I need to say, oh no, I don't think I do. Because we're at the end, because we're reading up to the end anyway. Oh. Maybe I'm talking nonsense. What was wrong with that reasoning? Oh, we're inside a loop here. Of course. That's what's wrong with that reasoning. So I think I'm right that anywhere that we're just reading a finite number of things, it's fine. But here we do need to say with input expression do, just so that we stop at the right place. Oh no, what I was saying was nonsense, because all of these reads, yeah, all of those reads are with respect to the current. What I said was just nonsense, because I'm not very clever and also really sleepy. This read here is with respects to, is reading from the expression, whereas the expression is just something that we read from the overall, from the S expression we were provided. So we have to dive into the expression to start peeking into it and start reading stuff from it, because as far as the outer S expression is concerned, it's already been read. So that is necessary. And then I think, well, we certainly don't need to say ASD_parser.new, but I think this can just be parse instructions. Please let that work. No. Hold on, what's... Oh. Oh, yeah, because we've accumulated... Right. So let's say with input, let's say body equals with input body parse instructions. How about that? Yeah. That's good. Okay, we're getting somewhere. Obviously some stuff needs to be broken out of this to make it more manageable. Okay. I think I can finish this before I fall asleep, so I'm going to power through just so that it's not hanging over me anymore, because this is some grim programming. Okay, how's this going to work? Case peak. Well, what do we want to do here? We definitely want to read something. So we can just do read straight away. But what does it go into? Let's just say read into expression. So I think I have to do this again. When it's an array, else. Because if it's an array, then it's this. So in here, let's say with input expression do, we're going to read into data. Oh, maybe this is parse string. Here, maybe if string was equal to the empty string, then it could just literally be this. Well, maybe it could be in here, because the other ones are. Because we want it to be nil if it's not, if we haven't come down here. So else, we'll say minimum size equals parse integer bits 32, which is way less gross than what we had there. Unless finished, maximum size equals parse integer bits 32. So I think that's it. No. Undefined local variable string. Yes, okay, so the scope of that needs to be up here. That seems extremely unlikely, but apparently it works. Oh, hold on. I mean, that's not the right value of it. It should be nil, not empty string. It's a bit weird that float memory passed in that case. It's not very rigorous. Oh. Crap. Okay, so that doesn't really work. Amazing that float memory works, but that work? It sort of does, doesn't it? Okay, what does store west do? Sorry, I've just stopped speaking now. Memory 1. Have I just misunderstood how parse integer works? Read into string. We are about to parse an integer. Okay, so what's going wrong? We're about to parse an integer. Oh, obviously. Okay, yes, I'm sorry. So this needs to be peak because yeah, similar thing to here. Okay. Parse memory. So this needs to be case peak. Read into expression here. And do the with input there. But here, we just do this. Yes. Okay, yeah, that was a category error on my part. We need to check to see whether it's going to be a nested expression or not. And if it is, then we're going to need we need to descend into that expression to read stuff out of it. But in this case, we don't because it's not nested. So we can just read stuff from it directly. That can just be like that. Okay, let me just run through the whole thing, but parse memory. Oh, I can almost taste it. We're nearly done. 40 commits. 6 hours. This is ridiculous. Why am I doing this project? This is the point when I'm just like, why did I choose to do this? I thought this was going to be fun and easy. A little fun project, I said. Okay. Put yourself together, man. Right, parse memory. All right, come on. We're pros at this now. I've just got 2 left. Any fool can do this. Okay, parse table. Yeah, this looks... well, actually, it looks a bit painful if I'm honest. Okay, let's just take it one annoying expression at a time. So, this is optional. So, if peak in then we do something. The thing that we do is that we read through this to get the name. Then we, with input read, do, because this is mandatory, we read into funcref. Oh. No, we just read. Sorry, we just read into funcref. That's it. It has to say funcref. All right, and now with input read, do, read into lm, and then elements we add read until finished. And then that's just saying that we're finished at that point. Parse table. I'm just going to make that commit. I don't care if it works or not. Okay, I slightly care about that. The thing is, I mean, obviously this is a bit painful because I didn't know what the sort of patterns of this parser were going to be, but now that I've typed very much like, you know, this is like a very common thing. Oh no. Stack.wast has... .196. Okay. Okay, what have I done wrong? So it could begin with a name, and if it does, we should read it. Done. Then it has to have, oh, this element, this LM thing is optional. It's optional. So we should only do this if we're not finished. Yes. And this is, please just pass because I've got to go to bed. And this is nearly the end. This is like the the last time that I was experiencing this specific emotion was when I was trying to finish Death Stranding, and every time and it was 2:00 in the morning again, and every time I thought I'd finished it, there was more ending. It wasn't 2:00 in the morning, it was midnight or something because other people in the UK were still awake, but it was very much this feeling of like, please, let this be the end. Okay, all right. What I was trying to say was that I feel like there are some standard pieces here that I can pull out into helpers, and I can decompose these huge methods into smaller methods, and it's all manageable. I've just gone about this in the most terrifying way possible. So no S expression. Okay, come on. This is a Unix system. I know this. So we have to read the name. We have to read with input, read, do. We have to read mut. And we have to read something that we don't care about. And we have to read value. So that stuff's all non-optional. Value equals parse expression value. So maybe instead of these two, value is just equal to parse instructions. Could that be true? Seems like it, doesn't it? Yep. Okay. That's all of them. I've moved all of the parsing out now. So now if we look at the interpreter, I mean, it certainly shouldn't have any methods that are to do with parsing. No, it just calls out to those. Well, that is a massive relief. That was I mean, I'm sorry, that was, if you're watching this, that was just such an unpleasant and boring thing to watch me slog through, but I have slogged through it. And now we're out the other side. And that's dealt with all of the syntax that I care about at the moment. I mean, obviously, as I implement new instructions, they're going to have to go in down here. But all of the stuff about scripts and stuff is now done. So that, frankly, is a massive relief. Let's do the traditional. Well, I'm sorry, Chris. I'm sure you're still watching. I'm sure you're still on your train at 2:30 a.m. I didn't get a chance to look at your PR. Sorry about that. But as you can see, I was doing something far more enjoyable, which was wrangling a parser. Okay, I'm calling it. Oh, that's old. Okay. I guess I deleted that tag. I was like, what about that tag that I made? But I guess I deleted it. It's definitely running them tests. There we go. Go green. All right. Well, I think we've all learned something important tonight, which is to never write a parser. Okay, well, I didn't achieve everything I wanted to achieve. But, you know, I got a chore done. So that wasn't the most exciting episode of whatever this is, but I feel like I've now finished extracting the AST parser, and it was a bit fiddly and not very fun, and it took ages, but it's done now, and hopefully I don't have to look at it anymore. I still don't have an identifier context, unfortunately, so I'm definitely going to have to do that next time. But maybe I'll try and make some test parse next time first, to just give myself a little bit of... I need to impart some more momentum so that I don't feel like I'm stuck in the mud, because that was really onerous, just grinding through all of that. Oh well, it's done now. Thanks for watching this. If you're watching this, especially this one, then let me know. Send me a tweet or a toot or whatever, an email, and let me know that you got to this bit, because I just find it impossible to imagine that anyone would have been able to sit through that. But clearly you did, because you're hearing this, so thank you. I'm going to go to bed. I'm really tired. But I'll say goodbye. Thanks so much for watching this. The next one will be better, I promise. We're gonna pick up the pace. We're gonna make some test pass. If nothing else, I need the momentum. So we're gonna come out of this trough and out of the valley of despair, and we're gonna climb the mountain of success or whatever. So I'll see you then. Bye bye.